All right, let's take a look at the practice test. For the instructions, we're asked to solve each triangle ABC. Remember, when we solve a triangle, this means we're finding all the missing side lengths. It also means we're finding all the missing angle measures. Additionally, we're asked to round your answers to the nearest tenth. Now, for these problems today, we're going to be given two angles and one side. So either angle side angle or angle angle side. So when you get this scenario, it's pretty much the easiest case. You can go immediately into using what we call the law of sines. We talked about where this comes from in the lesson if you want to look at that. But essentially, it's real easy to solve these problems. Let's just start off with problem number 1. We have a capital letter A and a capital letter C and a lowercase b. So let's remember what this means. If you have a capital letter, such as A or B or C, this is given to you for your vertices of the triangle. Right? So we're naming angles using this. So we would say that the measure of angle A is equal to 54 degrees. The measure of angle C is equal to 69 degrees. And then this lowercase b here, this is going to be for a side length that is opposite of your angle B. So the angle B and the lowercase b, those are connected. Okay? So the length of this side, again, denoted with this lowercase b, this is going to be 27 inches. So let's come down here and look at a little sketch. If you're working on these problems, I recommend making a sketch just so you have something where you can put the information down and see what's going on. The sketch does not have to be accurate. So first and foremost, we have our angle A. Again, that's 54 degrees. Our angle C, this is going to be 69 degrees. Angle B is unknown. So let's start by finding that. So we'll say that B is equal to the measures of all the angles in a triangle sum to 180 degrees. So we just do 180 degrees minus 69 degrees and then minus 54 degrees. And that's going to give me 57 degrees. So let's put 57 degrees in there. And let me erase this and make this a little bit more clean. So B is 57 degrees. Now, opposite of this angle B, you have this side, which has a length of 27 inches. Remember, we called this b, right? Lowercase b. So you could put this lowercase b is equal to this if you want, or you can just leave it off. It's really up to you. But what we're going to have to do is come down to this little formula here. Again, this is our law of sines. And you're going to plug in for this lowercase b, the known value, the length there is given as 27 inches. So let me write 27 inches. And this is over the sine of, again, the measure of my angle B was 57 degrees. So this is the ratio I'm going to use to find this lowercase a. Again, that's the length of the side opposite of angle A. And then also to find this lowercase c. Again, that's the length of the side that's opposite of your angle C. So let's come back and just grab the information. So again, the measure of angle A is 54 degrees. So we can just say this is equal to, again, put your lowercase a there over your sine of 54 degrees. So all we really have to do is multiply both sides by the sine of 54 degrees. So let's do this over here as well. And what that's going to do is isolate this lowercase a, what we're trying to solve for. This is going to cancel. And so you can just type this into your calculator now. Make sure you're in degree mode. A good way to check is to hit sine of 90. Hit enter and see if you get 1. If you do, you're in degree mode. Otherwise, you need to change things up. So to key this in, hit the sine key and then 54, then close the parentheses, then multiply by 27. Forget about the inches for right now. Then you're going to divide by, again, hit your sine key again, then type in 57, close the parentheses, and hit enter. So you're going to get that A is approximately, if I round this to the nearest tenth, it would be 26. And this guy right here is in terms of inches, so let me put that in now. Okay, so let's go back to this sheet right here, and I'm going to use, again, the lowercase a to denote the length of this guy right here. So this is approximately 26 inches. Now you can put it in right here as well. A lot of teachers like for you to do that, but I like to put an approximately symbol in, although it's not really required. Okay, so let me put my lowercase c here. So that's the length of this side. And again, we're going to use this angle right here, which is 69 degrees. So let's come down here. We just need to swap out some information. So let me undo that and that. And I'm going to erase that and erase that and erase that. So let me put in 69 degrees here and here. and then also here, and I'm going to change this to a lowercase c. Okay, so that's really all it is. So from this point, I'm just going to cancel this with this, and then just key this into my calculator now. So we'll say that this lowercase c is approximately, we're rounding to the nearest tenth, so I get about 30.1 if I round to the nearest tenth. So let's say this is approximately 30.1, and again, this is in terms of inches. So let's come back up and say c is approximately 30.1 inches. Again, that's the length of this side right here. So say this is approximately 30.1 inches. So we've officially solved our triangle. We found the two missing side lengths, and then we found the missing angle measure. All right, let's take a look at problem 2. So here we have the measure of angle B is 78 degrees. The measure of angle C is 66 degrees. And this lowercase b, again, this is the length of the side that is opposite of your angle B. So this is given to us as 15 feet. So once again, just make yourself a simple sketch. Doesn't matter if it's accurate, just something that you can put your numbers down on. So if we look at what we need, first off, let me find the measure of angle A. That's pretty simple. Just go 180 degrees minus 66 degrees minus 78 degrees. Punch that into your calculator, and you're going to get 36 degrees. So let me put here that the measure of angle A is 36 degrees. So what we have is this angle measure here, and the length of this side here that's opposite. So again, this is going to be lowercase b for this length. So let's come down here. For lowercase b, I'm going to put this as 15 feet. Again, the length of that side. This is over the sine of the measure of angle B was 78 degrees. Let me make this n a little bit better here. So let's start off with this guy right here. You have the lowercase a over the sine of, let's go back and see what that measure was. So this is 36 degrees. So let's come back here and say this is 36 degrees. Let me make this n a little bit better here. So again, all you need to do, let me drag this down, is just multiply both sides by the sine of 36 degrees. So multiply over here as well. So the sine of 36 degrees. And so this is going to cancel with this. And so you can just punch this into the calculator to approximate the value for this lowercase a here. So we have the sine of 36 degrees times 15, forget about the feet, over the sine of 78 degrees. And if I round to the nearest tenth, I get about 9. So let's say that this lowercase a is about 9 feet. So coming back up here, again, this is the length of this side that is opposite of your angle A. So this is approximately 9 feet. So let's put this lowercase a is approximately 9 feet. And we need to figure out the length of this guy right here. So this is opposite of your angle C. So let's call this length lowercase c. So lowercase c is approximately, let's go back down, and we just need to change some things up. So get rid of that, and that, and that, and that, and that. So the angle is now 66 degrees. So we'll put that in everywhere there. And we're trying to solve for lowercase c, right? The length of that side. So let's put this in there, and this is not going to be 9 anymore. And so let me show this as canceling right here. And so just key this into the calculator. And if I round to the nearest tenth, that's going to give me about 14. So lowercase c here is about 14 feet. So coming back, again, the length of this side right here, it's approximately 14 feet. So again, lowercase c would be approximately 14 feet. All right, let's take a look at problem 3. So here we're given that the measure of angle B is 40 degrees. The measure of angle C is 17 degrees. And then again, for the lowercase a, that's the length of the side that is opposite of angle A. So this is given to us as 43 yards. So again, making a simple little sketch here, we'll see that we first want to figure out what is the measure of angle A. So just do 180 degrees minus 40 degrees. That would give you 140 degrees. And then subtract away 17 degrees. That would give you 123 degrees. So let's put that the measure of angle A is 123 degrees. And then you want to figure out the length of this side right here. It's opposite of angle B. So we'll call this length lowercase b. And then over here, the length of this side, remember this is opposite of your angle C. So the length right here, we'll call this lowercase c. So let's take this piece of information, the measure of angle A, which is 123 degrees, and the length of this side right here, again, you can call that lowercase a, that's 43 yards. We'll build a little ratio out of that. So we'll put 43 yards over the sine of 123 degrees. And we'll set this equal to, again, just this guy and this guy. You're going to do them each, but individually. So let's go lowercase b over the sine of, what was the measure of angle B? Let's go back. That was 40 degrees. So let's put this in here like this. And maybe I'll make the 4 a little bit better. And we'll just multiply both sides here by the sine of 40 degrees. So let's do this over here as well. And then I'll show this as canceling. And we're just going to punch this into the calculator. We'll say this lowercase b is approximately, if we round to the nearest tenth, I get about 33. That's one of the ones where you have to carry, so it's a little bit tricky to round if you haven't done it in a while. But this is about 33 yards. So let's come back up here, and I'll say lowercase b is approximately 33 yards. So again, the length of this side right here, let's just put that this is approximately 33 yards. So I need the length of this side right here. Again, we're calling that lowercase c. So let me erase this and put a lowercase c. I'll erase this and this and this and this and this. Okay, so angle C, I forgot to get the measure there. If I come back up, it's 17 degrees for the measure of that angle. So we're just going to put in 17 degrees here and here, and then also here. So again, let me show this as canceling like that. And then we'll come through here and say that lowercase c is approximately, again, just punch this into your calculator. And I get about 15. So let's say this is about 15 yards. So we'll come back up here and we'll say that the length of this side is about or approximately 15 yards. Let me make the 5 a little bit better there. So we'll come over here. Maybe I'll write it up here and say that lowercase c is approximately 15 yards. All right, let's take a look at problem 4. So here the measure of angle A is 30 degrees. The measure of angle B is 89 degrees. And then the length of this side, which we're going to call C, is 21 yards. Remember, this is going to be opposite of our angle C. So coming down here, we have our little sketch. This angle B is 89 degrees. This angle A is 30 degrees. The length of the side opposite of our angle C is 21 yards. So this right here, we would call that lowercase c. And then this angle measure here, C, we could just do 180 degrees minus 89 degrees. That would give you 91 degrees. And then just subtract away 30 degrees and you would get 61 degrees. So almost a right triangle, not quite. You're 1 degree off right there. But this is not a right triangle. So we would say that this C guy here is 61 degrees. Okay, so we're going to use this and this to set up a ratio. So we're going to be working here. So let's go ahead and say that the length of that side, again, that's the lowercase c, that's going to be 21 yards. And this is over the sine of the measure of that angle C was 61 degrees. Okay, so let's say this is equal to, let's start with this guy. So the lowercase a, that's the length of that side that's opposite of your angle A. So this is over the sine of, what was the measure of angle A? Let's go back up. So this was 30 degrees. So this is 30 degrees. Now we know the sine of 30 degrees is a half. So you could plug that in, but I'm just going to leave it like this since we're going to punch it into the calculator anyway. So let me multiply by the sine of 30 degrees and multiply by the sine of 30 degrees. And this right here, let me use a different color, is going to cancel with this right here. So we'll just key this into the calculator and we'll say that the lowercase a here is approximately, if you round to the nearest tenth, I'll get 12, and this is in terms of yards. Let's come back. Again, so opposite of this angle A, this length right here is lowercase a, and this is going to be about, so approximately 12 yards. Again, I'll put lowercase a is approximately 12 yards. So again, the length of this side right here, which is opposite of this angle B, this is lowercase b. So let's figure this out. So the angle B has measure 89 degrees. We'll come back over here. I'm just going to erase here and here and here and here, and let's go here. So we're going to punch in. Oh, also I need to do here. So this is a lowercase b. This is 89 degrees. This is 89 degrees, and then this is 89 degrees, and this is a lowercase b. So what I'll do here is cancel this with this, and again, just punch this into the calculator, and I get about 24 when I round to the nearest tenth. So my lowercase b is going to be about 24 yards. So let's come back up here and say that this is approximately 24 yards. and I'll put this lowercase b. Again, the length of this guy right here, this is approximately 24 yards. Okay, let's take a look at problem 5. So here we're given that the measure of angle A is 38 degrees, the measure of angle C is 108 degrees, and then this lowercase c, which is going to be the length of the side that is opposite of my angle C, this is 34 kilometers. So let's come to our little sketch here. And again, everything is already set up. We just need this measure for angle B. So let's go 180 degrees minus 108 degrees, which is 72 degrees. Then I'll subtract away 38 degrees, and that'll give me 34 degrees. So let's put the measure of angle B is going to be 34 degrees. Okay, so the length of this side right here, which is opposite of my angle B, we'll call this lowercase b, and the length of this side right here, which is opposite of my angle A, we'll call this lowercase a. And so to figure out these two missing side lengths, again, we're going to use this angle right here and this side length. So let's go down here, and we're going to say for lowercase c, we know that that is 34 kilometers. And then we'll have over the sine of this angle C is 108 degrees. So let's say this equals, I'm going to put my lowercase a here over my sine of, if we go back, the measure of that angle is 38 degrees. So let's put 38 degrees here. And then I'm just going to multiply this by the sine of 38 degrees. And over here by the sine of 38 degrees. Okay, we already know the deal. This is going to cancel with this. And so we're going to have that this lowercase a is approximately, let's just key this into the calculator, and I get about 22. So let's say a is approximately 22 kilometers or kilometers, however you want to say that. So let's erase this and say the length of this guy is approximately 22 kilometers. And I'll put up here that a is approximately 22 kilometers, like that. Okay, I need the length of this side, so I'm going to use this angle here. So come down here. I'm going to erase this, and this, and this, and this, and this, and also this. So this would be a lowercase b now, and this would be 34 degrees, this would be 34 degrees, and then this would be 34 degrees. So let's cancel this with this, and just key this into the calculator. And if I round to the nearest tenth, again, this is one you have to carry, it's going to be about 20. So let's say that this lowercase b is approximately 20 kilometers. So coming back up here, I'll say that this is approximately 20 kilometers, like that. So the lowercase b is approximately, again, 20 kilometers. Okay, let's take a look at problem 6. So now we have the measure of angle A is 61 degrees. The measure of angle B is 30 degrees. And then this lowercase c, which is again the length of the side that is opposite of angle C, this is 24 kilometers. So let's come to our little sketch here. And again, let me just figure this one out first. So you can see this almost looks like a right angle, but it's not quite there because you have 30 degrees and 61 degrees, right? So if you had 30 degrees and 60 degrees, this would be 90 degrees, but now this is 1 degree more, so this would be 1 degree less. So this is 89 degrees. Again, you can always do 180 degrees minus 30 degrees, which is going to give you 150 degrees, and then 150 degrees minus 61 degrees will give you 89 degrees. So let me write here that the measure of angle C is 89 degrees. We know that the length of this side here, which we call lowercase c, is 24 kilometers. So let's come down here and set this one up. So this is 24 kilometers, and this is over the sine of 89 degrees. Okay, so we're going to use that to get this guy and this guy. So let's start with this guy. So I'm going to put this lowercase a over the sine of, again, if we go back up, the measure of angle A is 61 degrees. So let's put 61 degrees like this. And let me scooch this over here. I'm just going to multiply both sides by, again, the sine of 61 degrees. And so this is going to cancel. And so the lowercase a here is approximately, let's punch this in. And if you round to the nearest tenth, I get about 21. Again, that's one where you need to carry. So let's say this is about 21 kilometers. Let's come back up here, and I'll say that lowercase a, which again is the length of this side right here, this is approximately 21 kilometers. So let's say this is approximately 21 kilometers. Okay, so I need the length of this side right here. Again, that's opposite of your angle B, so we call that lowercase b. So let's get rid of this, and this, and this, and this, and this. So let me change colors here. I'll put a lowercase b in, and that angle B, if we go back, is 30 degrees. So let's put that in here, and here, and here. Again, we know the sine of 30 degrees is going to be 1/2. Let me put this lowercase b in there. But in this particular case, you can just leave it like this because we're going to punch it into the calculator anyway. So this would cancel. And so just key this into the calculator. So lowercase b is about 12 kilometers. So we'll come back up here and I'll say this is approximately 12 kilometers. And I'll write it over here. So this lowercase b, again, the length of this side is approximately 12. Let me make this one a little bit better. So 12 kilometers. All right, for the instructions now, we're asked to find the area of each triangle ABC. Again, we want to round your answers to the nearest tenth. Now, for the formula we're going to use, I want you to remember that you have to have side angle side, right? So it has to be side angle side, and the angle that you're given has to be the included angle between those two sides. Okay, so that's very important. So for problem 7, we have lowercase a. So remember, this is the length of the side that is opposite of your angle A. This is 12.2 miles. Then this guy right here, your angle B, has measured 67 degrees. And then this lowercase c, so the length of the side that is opposite of angle C, this is going to be 13.7 miles. Again, just make a little sketch so you can think about the information. We're not solving the triangle. We're trying to figure out the area. So all you really need to do is just eyeball this and see that you have side, angle, side. So this is the included angle, okay? So the formula would be 1/2 times this guy right here, so 13.7 miles, times this guy right here, so 12.2 miles. So this part's really easy to remember. So it's 1/2 times the length of this guy, times the length of this guy, then times the sine of the angle that's included, okay? So in this case, it's 67 degrees. Okay, so this is all it is. We're just going to punch this into the calculator. So to deal with the units now, we know that miles times miles would be square miles, or you could say miles squared, like this. So I'm just going to put the area is equal to, let me scooch this down here like this. Let's punch this into the calculator, and I get about 76.92. Let's just say that's 76.9 because we're rounding to the nearest tenth. So let me change this to approximately. So the area is approximately 76.9 miles squared, or you could say square miles. All right, let's take a look at problem 8. So here we have our lowercase a, and this is for the length of the side that is opposite of angle A. This is 7 centimeters. You have your angle C, which is going to be the included angle. This is 33 degrees. And then you have your lowercase b, again, the length of the side that is opposite of angle B. This is 13.3 centimeters. So coming down, again, you can make a sketch if you want to see this, or you don't have to in this case, but you have side, angle, side. So this is the included angle. So very important for us to use this formula that you have this set up. So the area is equal to 1/2, and then times, you're going to have your 7 centimeters, and then times your 13.3 centimeters. So you multiply 1/2 by this side, and then times the sine of that included angle. So this is 33 degrees. Okay, so that's all it is. So let's come down here and say that this is going to be approximately, we know that this is centimeters squared. Let me write that here because that's centimeters times centimeters. But everything else, just punch that into the calculator. And if you round to the nearest tenth, it's about 25.4. So we'll say the area here is approximately 25.4 centimeters squared, or you could say square centimeters. All right, let's take a look at problem 9. So here we have this lowercase c, which is our length for the side that is opposite of our angle C. This is 5 yards. Then we have our angle A is 25 degrees, and we have our angle C, which is 76 degrees. So in this particular case, you would look at this and say, well, I have angle, angle, and then side. So in order to use that formula, you need side, angle, side. So let's come down to a little sketch and think about what's going on. So you have an angle here and an angle here. Well, I could figure out what this angle here is if I wanted to. Do I need it? Well, again, you want side, angle, side, right? So side, angle, side, or side, angle, side. So whichever way you want to do it, I could just figure out what is this guy right here, which is going to be lowercase b? So what is this length right here? And then I could go side, angle, side like this, or I could figure out this angle, and I could figure out this side, and I could go side, angle, side like this, or I could go side, angle, side like this. So what I would have to do is go back to my law of sines. So we would say that we have lowercase c, which is the length of this side right here. It's 5 yards. So let me put 5 yards over the sine of this angle here, which would be 76 degrees. So the sine of 76 degrees is equal to, in this case, you would have the length of this guy right here, which we call lowercase b, over the sine of this angle b. So the sine of this angle b, which is unknown at this point, but again, you could just do 180 degrees minus 25 degrees minus 76 degrees. That's going to be 79 degrees. So let's put 79 degrees in like that. So what you would end up doing is multiplying both sides by the sine of 79 degrees. So let me actually erase this from over here. Kind of a tight space. So let me just drag this over here temporarily, and I'll just move this over here, put times, and then just drag this up here like this. Okay, we're just going to key this into the calculator. And if I round to the nearest tenth, I get about 5.1. So let's say this is approximately 5.1 yards. Let's get rid of this. And now I can do side, angle, side. Now keep in mind you're using an approximate value here. As you use values that are approximated more and more, your results get less and less accurate. So that's just something to keep in mind. So the area here would be approximately 1/2 multiplied by 5.1 yards multiplied by 5 yards, and then multiplied by the sine of, in this case, this would be your included angle. So you have side, angle, side. So the sine of 25 degrees. So this would be, let's just punch this into the calculator, 1/2 times 5.1 times 5 times the sine of 25 degrees. And I get about 5.4. So let's say this is about 5.4 square yards. So 5.4 square yards, or yards squared. All right, let's take a look at problem 10. So our lowercase a, which again is the length of the side opposite of angle A, that's 8 meters. Then we have the measure of angle B is 74 degrees, and the measure of angle A is 56 degrees. So again, you have two angles and a side, so we don't have all the information to get the area. So again, we have to go back to our law of sines, and you just need to do side, angle, side, or you can do side, angle, side, or you can do side, angle, side, whichever one you want to do. But again, I'm given this side right here and this angle right here. So I probably just need to figure out this side right here. And so let's just think about this guy and this guy. So we would say that your lowercase a, again, the length of this side right here is 8 meters over the sine of this angle A, which is 56 degrees. Maybe I can make that a little bit cleaner there. This is equal to, again, if I want this guy right here, well, I need this angle right here. So 180 degrees minus 56 degrees minus 74 degrees, that's going to be 50 degrees. So we'll go ahead and say this is lowercase c over the sine of 50 degrees. Again, all you would do is multiply both sides by this guy. So let me move this over here like this and get rid of this and just punch this into the calculator. And I get about 7.4 if you round to the nearest tenth. So let's say this is approximately 7.4 and this is meters. So we'll say the area is approximately, we'll say 1/2 times the length of this guy, which is 8 meters, times the length of this guy, which is going to be 7.4 meters, and then times the sine of that included angle. So again, we're going side, angle, side, so the sine of 74 degrees. Okay, let's punch this into the calculator, and I get about 28.5. And again, this is in terms of meters squared. So 28.5 meters squared, or you could say square meters, whatever you want to do. All right, let's take a look at the practice test. For the instructions, we're asked to solve each triangle, ABC. We want to round your answers to the nearest tenth. All right, for the problems we're going to look at today, they're going to deal with the law of sines with your ambiguous case. So this is a much more tedious scenario. You really have to dig into the details of the problem a little bit. And basically, you're going to be given side-side angle here. And so you're going to have an angle that's given and then a side opposite, and you're going to have another side. Now, if the angle that's given is an obtuse angle, you're going to have two possible scenarios. You can have one triangle or no triangle. If the angle that's given is an acute angle, well, now you have four possible scenarios. You can have no triangle. You can have two triangles. You can have one triangle that's not a right triangle, and then you can have a right triangle. So let's start off with this first problem here. I think it's going to be the easiest scenario because we're given an obtuse angle. So here, the measure of angle A is 94 degrees. We have our side C. The length is going to be 16 meters. And then our side A, remember, this is going to be the side that is opposite of this angle A. This has a length that's 16 meters. What you can do is sketch a little picture and just think about what's going on. So here's my angle A. Again, it's 94 degrees. So this is an obtuse angle because it is greater than 90 degrees and less than 180 degrees. And here's my side A that is opposite of this angle A. You see I've labeled it as being 16 meters. And then here's my side C, which is also 16 meters. So in this case, you can immediately say that no triangle will exist. Because again, if you have an obtuse angle in a triangle, then it must be the largest angle in that triangle. If you take the sum of all the measures of the angles in a triangle, it's going to be 180 degrees. So if you took 180 degrees and you subtracted away 94 degrees, well, you're going to get 86 degrees. So this right here, if you did have a triangle, would be the sum of the other two angles. So you know if you have an obtuse angle that it's going to be the largest angle in that triangle. And from basic geometry, we know that opposite of your largest angle, you're going to have your longest side. So this guy right here, this side A, which is opposite of your angle A, again, the largest angle, it should be the longest side, but you can see that it's not, right? This is 16 meters, and this is also 16 meters. They cannot be equal, right? This needs to be greater than this, even if it was something like 16.01 or whatever it is. At that point, you'd be able to draw a triangle, but if these guys are equal, or if this guy right here is less than this guy right here, you do not have a triangle. So you could just put that no triangle exists or no triangle, or there's lots of different ways to write this out. Let me just put that no triangle exists. And that'll be my answer. Okay, let's take a look at problem 2. So another easy one. So here we're given the measure of angle A is 147 degrees. So again, we have an obtuse angle that's given. It's greater than 90 degrees and less than 180 degrees. We're given that the length of this side C is going to be 25 miles. And then the length of this side A is 4 miles. So again, this side right here is opposite of this angle right here. So you can draw this if you want. But again, you can see that this guy right here, which is opposite of this angle here, this should be the longest side. But clearly 4 miles is less than 25 miles, so you can't draw a triangle. If you come down here, let's just say it looks something like this. So here's A is 147 degrees. Here's your side C. Again, this is 25 miles. And then here's your side A, again, opposite of your angle A. It's only 4 miles, so you can't create a triangle with this. This side A that is opposite of your angle A should be the longest side, but it is not, right? So no triangle exists. So let's say no triangle exists. All right, let's take a look at problem number 3. So I'm just going to tell you in advance this problem is more tedious because we have an acute angle involved. So for the measure of angle B, this is going to be 46 degrees. For side A, the length is given as 50 kilometers. And then for side B, which is the side that is opposite of this angle B, the length is given as 47 kilometers. Now, for this type of problem, you can go straight into using the law of sines. And with that, you can immediately determine if you have 0 triangles, 1 triangle, or 2 triangles. Okay, so that's the quickest way to do this. In most scenarios, you're just going to do that. For the sake of the tutorial, I'm going to take an extra step here, and I'm going to think about things geometrically. So what I'm going to do is come to a little rough sketch. This is something you can make on your own. So the angle that's given, in this case, it's B. I'm just going to put this over here. And again, this is a rough sketch, so this is not going to be accurate, but I'm just going to put in here that this angle is 46 degrees. Now the side that is opposite of this, again, this lowercase b here, we are told that this is 47 kilometers. And then the other side that's given, let's say this is lowercase a here, this is 50 kilometers. So we know that if a triangle exists, that this guy over here would be your uppercase A, right? Your angle over here. But at this point, we don't know if a triangle exists. So this step would confirm whether you have 0 triangles, 1 triangle, or 2 triangles. Okay, so this is something you can do. So the first thing is you're going to think about this H, or the height, right? So from right here to right here. So how do you do that? Well, you go back to your SOHCAHTOA. So let me actually draw this in. So this is crystal clear what we're looking at. And let me draw this in like that. Not perfect, but I think you get the idea. So this is the right triangle we're looking at. So basically you can say that the sine of 46 degrees is equal to the opposite, which is H, or the height here, over the hypotenuse, which is A. In this case, the length is given as 50 kilometers. So what you can do is solve for H, or the height. And this would be equal to multiply both sides by 50 kilometers. So we would say this is 50 kilometers times the sine of 46 degrees. Let me get rid of this. And if you punch that into the calculator, you're going to get about 36 kilometers if you do some rounding. So let's say that H, and I'm just going to put equals, even though it's an approximation. This is 36 kilometers. Okay, let me get rid of this. Now, first and foremost, if this side right here that is opposite of this angle that's given, if this guy is less than the height, then you can stop and just say no triangle exists. You are done with the problem, right? Because this side right here will not be long enough to make a triangle. If this side right here is equal to the height, well, then you have one right triangle. If this side right here is greater than the height, but it's less than this side over here that's given, then that's where you're going to have 2 triangles. So here you can see that that's going to be the case. Now, the last scenario is you have 1 triangle and it's not a right triangle. So that's going to be when this side right here is greater than or equal to this side over here. Okay, when that happens, you have 1 triangle that's not a right triangle. So in this particular case, again, you could arrange this and say that your H, or your height, is the smallest value. This is going to be less than your B. And then this is going to be less than your A. So when this occurs, again, this side right here that is opposite of this angle, when this guy is greater than the height and less than this other side that was given, you are going to have 2 triangles. Okay, let's get rid of this. We don't need this information anymore. We know at this point there's going to be 2 triangles. Now, here's where I go into the law of sines. So if you wanted to skip what I just did, you would start at this point. I would first try to figure out what is the measure of this angle A. To do that, I would say that the sine of A over, again, this side A here, the length is 50 kilometers. This is equal to, I'm going to go the sine of B. In this case, the angle B is 46 degrees. And this is over the length of this side B, which is 47 kilometers, like this. Okay, let's solve for the sine of A. Let me grab this real quick. And what I'm going to do is multiply both sides by 50 kilometers. And so this will cancel. And so you have the sine of A is equal to the sine of 46 degrees over 47 kilometers times 50 kilometers. Now, let me actually erase this. I don't think we need this over here anymore. And actually, I'm going to cancel these units away. And just punch this into your calculator. And I get about 0.76. And I'm going to go 5.2. And you can put more digits if you want to make this more accurate, but maybe I'll just stop here and round this up to a 3. Okay, so let's just stop there. So this is my approximate value for the sine of A. Now that's not the measure of angle A, this is the sine of A. Now, here's where, if you skip the first step where you find the height, you would immediately know if this guy is greater than 1, that you have no triangle. Okay, so you just stop and say no triangle exists. If it's equal to 1, well, we know that the sine of 90 degrees is going to be 1, so that tells me that I have a right triangle. If you go back, that would tell me that this angle A would be this right angle here, which is 90 degrees. And so this side right here, this lowercase b, that is opposite of the angle B that's given, it would exactly be equal to the height in that case. Now, the other scenario, again, is the scenario we have here, which is where this guy right here is greater than 0 and less than 1. So in this case, you have to actually check for 2 triangles if you didn't do the step above. So let's do our sine inverse to see what this gives me. So I'll say that A is equal to the inverse sine of this value right here, so 0.7653. Let me make that 5 a little bit better. And I'm just going to say this is equal to, I'll say it's about 49.9 degrees. I'm just rounding to the nearest tenth. So that would be my first measure for angle A. Because I know I have two triangles, I'll just call that A sub 1. Let me slide down here a little bit. Now, we know that supplementary angles have the same sine value. So what you're going to do for A sub 2 is you're going to say that this is 180 degrees minus this 49.9 degrees, and this is going to give me 130.1 degrees. Okay, so this is my A sub 1 and this is my A sub 2. So these are for two different triangles. Now, if you didn't check the height, at this point you've got to take this guy right here and you've got to add it to that original angle you were given, which was B, and you've got to see if it's less than 180 degrees. It can't be equal to 180 degrees, it has to be less than. So if you take 46 degrees and you add that to 130.1 degrees, this is going to give you 176.1 degrees. So that tells me there's room for another angle there. So if this is less than 180 degrees, you have two triangles. If it's greater than or equal to 180 degrees, then in this case, you would only have one triangle. Okay, but we have two. So let's just go ahead and say that this is our A sub 1 and this is our A sub 2. So let's come down here to the first triangle, and I've already labeled everything. We already know that this guy for A, the measure is 49.9 degrees. We know the side opposite is 50 kilometers. We know that our angle B is 46 degrees. We know the side opposite is 47 kilometers. And then for angle C, this is just me saying 180 degrees minus 46 degrees minus 49.9 degrees. That gives me 84.1 degrees. And then for this side opposite, this lowercase c, which is 65 kilometers, again, you just use your law of sines. So start with what you were given so you get a more accurate answer. So we'll say that this B here over the sine of B, again, this is the side B, the length of that, and this is your angle B. So this is equal to, again, the length for this side right here, let's call that lowercase c, over the sine of this angle here, C. So I'm just going to plug in what I know. So the length of this side, again, this is lowercase b, this is 47 kilometers. And then for the sine of B, again, B is 46 degrees. Let's plug that in there. And then for the sine of, again, this angle C, this is 84.1 degrees. And just multiply both sides by the sine of 84.1 degrees. So you're going to get this lowercase c, or the length of this side, is equal to, I'm going to say this is 47 kilometers over the sine of 46 degrees times the sine of 84.1 degrees. Okay, let me get rid of this and just punch this into the calculator. And I get about 991. I'm just going to stop there. I'm going to round it to 65 kilometers. Again, here I'm just using equal signs where if you wanted to be more accurate, you would use approximately. So this is approximately 65 kilometers. This is approximately 84.1 degrees. This is approximately 49.9 degrees. But this was given, and this was given. Okay, so if you wanted to make something that's completely accurate, just make sure you indicate what's an approximation and what's actually a given value. Now let's come down and think about the other triangle that can be formed, and then I'll go ahead and put the two together. Okay, so for this one, we know that we had an angle of 46 degrees. This was your B. And then you had an angle of 130.1 degrees. This was your A. So we figured that out already. So to get this angle here, which is 3.9 degrees, again, all you have to do is 180 degrees minus 46 degrees minus 130.1 degrees. That's going to give you that 3.9 degrees. Now for the length of this side here, again, you just do the same thing that you set up. So you're going to say that this lowercase c is equal to, you would have the length of this side B, which is 47 kilometers, over the sine of the measure that angle B is 46 degrees, and then times, you would have the sine of this angle C, which in this case is 3.9 degrees. Okay, let's punch that into the calculator. I'm just going to round this to 4.4, and this is in terms of kilometers. All right, so we understand how we get the two triangles, and we understand what the two triangles look like. Let's finish this up by just putting everything together into one little sketch. So first off, you see that there are two triangles that are formed, and you can think about this guy as like a hinge, right? So in the first triangle, let's just say it's this triangle right here, and I know I'm not sketching that accurately, but let's just say it's this bigger triangle here. You can see that you have this A sub 1, which the measure of that was 49.9 degrees. In this case, this angle C, it's the whole thing there. This would be 84.1 degrees. And the measure of angle B is always going to be 46 degrees, whether you have the bigger triangle or the smaller one. Okay, so that's this guy. And so this side length, which is opposite of this angle B, lowercase b, is 47 kilometers no matter what. And then this side length here, which is opposite of angle A, is always going to be 50 kilometers no matter what. But the difference is the side length here, let me highlight that. So this guy from A sub 1 all the way to B, that's going to be 65 kilometers. So let me arrow to this and say it's 65 kilometers, and that's an approximation. And you can see that's, again, all the information for the bigger triangle. Now, if you want to draw the smaller triangle, let me get rid of this right here. Well, now, again, this right here is going to swing like this, okay? So you can see that this side right here is the same, this side right here is the same, and this angle is the same. What's changing is now the measure for angle A, right now we call it A sub 2. And so the measure of this guy is now 130.1 degrees. And then the measure for angle C, let's just call it C sub 2 if you wanted to. This guy's going to now be 3.9 degrees, okay? So that's forming this triangle right here. And in this particular case, the length from A sub 2 to B, this is going to be 4.4 kilometers. So hopefully you can see that there's just two different ways you can draw this triangle. Either you have this smaller triangle, again, from this guy swinging like this, or you have the bigger triangle, this guy right here, the whole thing. All right, let's take a look at problem 4 now. So here, we have another obtuse angle, so this is the easier scenario. The measure of angle B is 114 degrees. Then the length of this side A is going to be 44 inches, and the length of this side B is 78 inches. So remember, this right here, because it's an obtuse angle, it's the largest angle in your triangle. And so the side that is opposite of that, so this guy right here, should be the longest side. So this right here needs to be greater than this right here. And it is. 78 inches is greater than 44 inches. So that tells us we have exactly one triangle. So once you figure that out, just go into your law of sines to get what you're missing. So you need the measure of angle A, you need the measure of angle C, and then you need the length of side C. Okay, so let's go ahead and say that the sine of this angle A over the length of this side A is 44 inches. So 44 inches. This would be equal to the sine of your angle B, so in this case, the measure is 114 degrees, over the length of side B, so that's 78 inches. Okay, let's grab this real quick, come down here and paste this in and see what we can do. So I want to solve for the sine of A, so let's multiply both sides by 44 inches. And basically, let me make this a little bit clearer there. Basically, this is going to cancel with this. So that leaves me with the sine of A by itself on the left. Let me just erase this. And then you can cancel these units away. So I'll put the sine of A, and I'll just use equals. I just want to make it clear that I am approximating this. I am punching this into my calculator. So the sine of 114 degrees times 44, and then divided by 78, that's going to give me, let's say, about 0.5153. So let me put 0.5153. So if you want to figure out what is the measure for angle A, again, this is an approximation, but I'm just going to put equals. You're going to do the inverse sine of this guy right here, so 0.5153. So that's going to give me, let's say, about 31 degrees. So 31 degrees. So that tells me the measure of angle C would be 180 degrees minus 114 degrees minus 31 degrees, and that's going to be 35 degrees. So let's say C is equal to 35 degrees. And again, the measure of angle A and the measure of angle C, those are both approximations. All right, so coming down to this little sketch here, again, for the measure of angle C, we said it was about 35 degrees. For the measure of angle A, we said that was about 31 degrees. And for angle B, that's given to us as 114 degrees. The side opposite of our angle B is, again, called lowercase b. The length there is 78 inches. And the side opposite of our angle A, we call that lowercase a. The length is 44 inches. And then the side opposite of our angle C, this is lowercase c. I'm giving you that it's 49 inches, but again, we need to figure out where that came from. So you're just going to say that this lowercase c, or the length of this side here, over the sine of your angle C, so this is 35 degrees for the measure, is going to be equal to, again, the length of this guy right here. So the lowercase b, that's going to be 78 inches over. You want to take the sine of this angle here, which is B, so that's 114 degrees. So the sine of 114, let me make this a little bit cleaner here, degrees. Okay, what you would do is just multiply both sides by the sine of 35 degrees. And we'll just punch that into the calculator. And that's going to give me 48.972. And again, I'm just going to round this to the nearest tenth. So we'll say it's about 49 inches. So that's where this value comes from. So again, we were given this information here, here, and here, right? So these two sides in this angle. We estimated that the measure of angle C is 35 degrees. The measure of angle A is 31 degrees, and the length of this side, let's call it lowercase c because it's opposite of the angle C, it's about 49 inches. Okay, let's take a look at problem number 5. So here we have an acute angle again. So the measure of angle C is 77 degrees. Then the length for side B is 49 centimeters. And then the length of side C, again, this side is opposite of this angle given, that's going to be 6 centimeters. Now, it looks pretty suspicious. If you sketch something pretty basic, you can get an idea that this is not going to form a triangle. Now, you can confirm your suspicion in two ways. Again, we can go back to getting the height. And so let's say this is h. So we can say that the sine of 77 degrees is equal to the opposite, which is h, over your hypotenuse, which in this case is b, but we would say the length here is 49 centimeters. Okay, we'll multiply both sides by 49 centimeters. So you would say h is equal to 49 centimeters times the sine of 77 degrees. So let's punch that into the calculator and see what we get. If I round to the nearest tenth, I get about 47.7. Okay, so let's say that this is about 47.7, and this is in terms of centimeters. Now, we talked about this earlier. If this guy right here, this side that is opposite of this angle given, if it is less than the height, then this guy right here, this side is not long enough to create a triangle. So you can immediately stop and say no triangle exists. So let's put that no triangle exists. Okay, so you can just stop at that point. Now, the other way to do this, if you don't want to sketch anything, you can just immediately go into the law of sines, and you're going to see that you're going to get a sine value that's greater than 1. So this is the other strategy. So what you can do is say, well, I want to figure out what is the measure of this angle B that would be over here, right? So this is opposite of this side B that was given. So you can say that the sine of B over this length here for lowercase b, that side, this is 49 centimeters, would be equal to, you would have the sine of your angle C that was given, so let's say this is 77 degrees, over the length of this side C, which is 6 centimeters. So what we would do here is multiply both sides by 49 centimeters. And so this would cancel, and centimeters would cancel. So let's cancel those units there. And what you're going to have is that the sine of B is equal to, you have the sine of 77 degrees times 49 over 6. So punch that into your calculator. You're going to get about 8 if you round to the nearest tenth. And we know that the sine of some angle, whatever it's going to be, is going to be between -1 and 1, where -1 and 1 are included. So here you just think about the fact that if the sine of whatever this is, in this case it's B, if that's greater than 1, then you know that we're in a situation where no triangle exists, right? Because we're outside of the range of the sine function. All right, let's take a look at problem 6. So here we're given that the measure of angle A is 45 degrees. We're given that the length of side C is 44 miles. And we're given that the length of side A is 34 miles. So remember, this side A is opposite of this angle A. Now again, if you want to go through this geometrically, you could sketch this out and then look at the height, and then you could figure out what scenario you have. But it's actually quicker if you just use the law of sines. So the first thing I would try to do is figure out what is the measure of angle C. And basically, if I end up with a sine value that's greater than 1, I could just stop and say no triangle exists. So this is the shorter way to do this. So let's go ahead and say that we have the sine of A. In this case, A is 45 degrees for the measure. This is over the length of side A. That's going to be 34 miles. Let's make that 3 a little bit better there. This would be equal to the sine of our angle C. We don't know the measure of that right now. That's what we're trying to figure out. And this would be over the length of side C. That's going to be 44 miles. Okay, so I'll multiply both sides by 44 miles. And so this right here is going to cancel with this right here. Your miles are going to cancel over here. Let me actually erase this, and I'm just going to key this into the calculator. So 44 times the sine of 45 degrees over 34. And that's going to give me about, let's say, I'm going to go 915, and let's say 1. So I'll say that the sine of C, and again, it's an approximation, but let's just put equals. I'll put 0.91, and I'll say 5, 1. So I'm going to use my inverse sine function. Let's get rid of this. And you notice that this value here is between 0 and 1. So we know that we have a triangle. We just don't know, do I have one triangle that's not a right triangle, or do I have two triangles? Again, if this guy right here had been 1, well, then I know I have a right triangle. But because it's between 0 and 1, I've got to check some stuff. So let's go ahead and say that C is equal to the inverse sine of this right here. So 0.9151. Let's key that into the calculator. And if I round to the nearest tenth, I get about 66.2. So let me erase all of this. And I'm going to say that the measure of angle C, and I'm going to call it C sub 1, just in case I have two triangles, I'm going to say this is 66.2 degrees. Here's where you have to do a little bit of math. The first thing is you need to figure out, well, what would C sub 2 be? So let's go C sub 2. This is equal to, again, supplementary angles have the same sine value. So you're going to go 180 degrees. That's the sum of supplementary angles. Then minus this guy right here. So 66.2 degrees. And that's going to give me 113.8 degrees. So let's put here that this is 113.8 degrees. If you have two triangles, you have to have room for another angle. So what you want to do over here is check this angle right here that's given. This is not moving, right? This is always going to be 45 degrees plus this proposed angle here. See if it's less than 180 degrees. So we would say that 45 degrees plus 113.8 degrees, that equals 158.8 degrees. So that tells me I have room for another angle. So there's two triangles. Okay. So again, you could have done this by finding the height, and you would have seen that this guy right here is greater than the height and less than this guy right here, this other side given. So let's actually erase this real quick. And I'm just going to put my B sub 1 here and then my B sub 2 here. Again, that's just the angle B in each case. So in this case, you would take 180 degrees, subtract away 45 degrees, and then subtract away 66.2 degrees. And that's going to give you 68.8 degrees. For B sub 2, here you would do 180 degrees minus 45 degrees minus 113.8 degrees, and that's going to give you 21.2 degrees. Okay, so I've already drawn these guys out. Let's just go down to the first one. So see, for this case, the measure of angle C, which again is approximated, it's 66.2 degrees. The measure of angle B is about 68.8 degrees, again, another approximation. And the measure of angle A is given, so that's 45 degrees. We know that's accurate. Now, we were given that the length of side A is 34 miles, and the length of side C is 44 miles. So that's where this comes from and this comes from. We would need to get this 44.8 miles. That's an estimate for the length of side B. So how do you find that? Again, you go little b, like this, the length of this side, over the sine of this angle B. So this is 68.8 degrees. This is equal to, again, you could take what was known. So you had a measure for angle A of 45 degrees and a side length for A of 34 miles. So let's go 34 miles for the length of side A over the sine of 45 degrees. Now we know the sine of 45 degrees is square root of 2 over 2, but I would not replace that. I would just punch this into my calculator and be done with it. So you're going to end up multiplying both sides by the sine of 68.8 degrees. So let's say that the length of this side B here is going to be equal to 34 miles over the sine of 45 degrees times the sine of 68.8 degrees. So if you punch that into your calculator, you get about 44.829, so on and so forth. I'm just going to round that to the nearest tenth and say it's about 44.8. So that's where we're getting this 44.8 miles here. Again, the length of this side B. Looking at the other triangle that is possible, the measure of this angle A is 45 degrees. what's going to change is the measure of angle C. Now it's 113.8 degrees. And the measure of angle B, now it's 21.2 degrees. And then the side B, that's going to change. So this right here, the length of side A, that's the same, it's 34 miles. And the length of side C, that's going to be the same, it's 44 miles. So to get this guy right here, again, you could just say this length of the side B over the sine of B. Now we know we're going to end up multiplying both sides by the sine of 21.2 degrees. So let's just do that over here. I'm going to put this as times the sine of 21.2 degrees just to speed things up. So this over here, the ratio would be, I'm going to take this side A, the length of that's 34 miles over the sine of A. Again, the measure of this is 45 degrees. So this is the sine of 45 degrees. Again, all I did was speed up the process. We would have divided the length of this side B by the sine of 21.2 degrees. So you multiply both sides by the sine of 21.2 degrees. It cancels from over there and you have it over here. That's all we did. So just punch this into the calculator and I get about 17.3880. And then again, it continues on, but I'm just going to round this to the nearest tenth and say it's about 17.4. So that's where this guy comes from, this 17.4 miles. Okay, so you see the two triangles that we set up. You see that in each case, you have a measure of angle A of 45 degrees. What's changing is the measure for angle C and B, and then also this guy and this guy. So the length of side A and the length of side C, those are fixed. But the length of this side B is going to change based on which triangle you're drawing. All right, let's take a look at problem 7 now. So we have the measure of angle A is 82 degrees. We have the length of side C is 46 meters. And we have the length of side A is 5 meters. So again, side A is opposite of this angle A. So these two form a pair. Now we can make a rough sketch. You don't have to, but you can. I think it's pretty suspicious when I look at this 5 meters here, and it's way less than this other guy, which is 46 meters. That tells me that I probably can't make a triangle. So again, you could use the law of sines immediately to confirm this. You're going to get a sine value that's greater than 1, or you can use the height. And remember, if this side right here that is opposite of that angle given, if it's less than the height, you are not going to be able to create a triangle. So let's say that we make ourselves a little right triangle here. So this would be my height. And then if I go sine of 82 degrees, so sine of this angle here, its opposite, which in this case is going to be the h or the height, and then over the hypotenuse, which in this case is C. And we're given a length that's 46 meters. So just multiply both sides by 46 meters. So you would have that h is equal to 46 meters times the sine of 82 degrees. Let me get rid of this. And you can just key this into your calculator. And I get about 45 point, let's say 6 if I round to the nearest tenth. So we'll say that this is about 45.6 meters. And this is an approximation, even though I'm using an equals sign. All I'm looking at here is this side right here less than the height? Yes, right? So this is not going to be long enough to create a triangle. So you can just stop and say, no triangle exists. No triangle exists. Okay, and you can be done with it. The other way, which is probably quicker than making a sketch, you would think about, okay, let's say I didn't have this information. I didn't have a sketch. I just have this angle, this side opposite, and this side here. Okay, well, the first thing I'd try to do is figure out what is the measure of angle C. So if there was a triangle, angle C would be somewhere over here. And I would just say, okay, well, the sine of C over this length for the side C, so this is 46 meters, would be equal to the sine of my angle A that's given. In this case, it's 82 degrees. And this is over the length that's given for this side A, which in this case is 5 meters. So since I want to solve for the sine of C, let's multiply both sides by 46 meters. So let's multiply over here. And we can see that this would cancel with this. You can even just erase it just to make it a little bit more neat. And then the meters would cancel over here. Just punch this into your calculator and you're going to see you get a problem. When you do the sine of 82 degrees times 46, and then you divide by 5, you're going to get something like 9 point, let's just say 1 if we want to round to the nearest tenth. So because the sine value here is greater than 1, we can just stop and say that no triangle exists. Okay, let's take a look at problem number 8 now. So here we're given the measure of angle C is 27 degrees. We're given the length for side B is 44 inches. And we're given the length of side C, that's going to be 32 inches. Now again, you could make a rough sketch and figure out what the height is, but for myself, again, if I'm solving these problems on my own, I typically don't do that. That's just more or less to get an idea of the full concept and what's going on. I would immediately go into the law of sines and I would try to figure out, well, what is the sine of the angle B? So the angle that's across from this side here. And if I can figure that out, if the sine value is greater than 1, then no triangle exists. If the sine value equals 1, well, then I have a right triangle. And if the sine value is less than 1, well, then I need to check to see, do I have one triangle or two triangles? So let's go straight into that. We'll say the sine of our angle B over little b here, the length of this side B, so this would be 44 inches. This is equal to, we would have the sine of our angle C, so C, the measure is 27 degrees. This is over the length for this side C, so the length is given as 32 inches. What I can do is multiply both sides by 44 inches. So let me do that over here as well. And I'm going to cancel this with this. And so I have that the sine of B is equal to, you have the sine of 27 degrees over 32 inches, and then times 44 inches. And actually, let me cancel the inches away, and I'll just erase it from here. That way we don't deal with it. And then essentially just key this into your calculator, and I get about, and I'm going to use an equal sign even though it's an approximation, let's say 0.62, and I'm just going to go 42 like this. Let me get rid of this step here. And I'm just going to slide this down like this. So you can see that this is between 0 and 1. So basically that tells me that we do have a triangle. So we could have one triangle or two triangles at this point. Let me get rid of this. We don't need this information anymore. And I'm just going to figure out what is B. And I'm just going to call it B sub 1 because I might have two triangles. So I would do sine inverse of this guy right here. So we'll say that B is equal to the inverse sine of this right here, so 0.6242. So keep in mind, this is an approximation. I get about 6 degrees. So 38.6 degrees. So let me get rid of this. And actually, I'm just going to write this up here. So this is 38.6 degrees. Okay, let me make that a little bit better. Now, here's what you need to do. You need to write out B sub 2 in case you have a second triangle. And the way you figure this out is you go 180 degrees minus whatever you calculated there, and that's going to give you 141.4. So this is 141.4. So remember, supplementary angles have the same sine value. So I have this guy and this guy, but you have to check to make sure that there's room, okay? So the final check here is to take this angle here and add it to this one that was given. So in other words, we would say 27 degrees plus 141.4 degrees, that has to be less than 180 degrees for you to have a second triangle. If it equals 180 degrees or it's greater, you don't. So if I perform this addition, I get 168.4 degrees. So that tells me I have two triangles. Let's get rid of this. And let's say now that this is A sub 1. And again, you just do 180 degrees minus 27 degrees minus 38.6 degrees. And that's going to give me 114.4 degrees. And then over here, I'm going to go A sub 2. And again, to get this one, I go 180 degrees minus 27 degrees minus 141.4 degrees. Let me put the degree symbol in there. And that's going to give me 11.6 degrees. So now I have the information to build my triangles. Again, in each case, I know that the side B is 44 inches in length and the side C is 32 inches in length. I would just need to figure out what is side A here and what is side A here. So you could do it here and then go to the triangle, but I've drawn each one. So let me actually go down to the first one. You can see that for this one, my angle B is 38.6 degrees. Again, it's an approximation. And then my angle A is 114.4 degrees. So these guys, again, are going to change when we go to the next triangle. This guy for C is going to be 27 degrees no matter what. Now, this side right here, which is 44 inches, this is my little b, or my side opposite of my angle B. That's always going to be 44 inches. And then this side C here, which is opposite of my angle C, that's always going to be 32 inches. But this side right here, which is little a, opposite of my angle A, that's going to change, right? So right now I'm saying it's 64.2 inches. And again, if you want to get this, you would take little a, which is the length of this side here, over your sine of A, the angle measure there, that's 114.4 degrees. This would be equal to again, you could use this one right here and this one right here. So let's say that we're going to use little c, which is 32 inches. Again, that's the length of this side right here. And this would be over the sine of, in this case, this angle C, that's going to be 27 degrees. So what I would do is multiply both sides by the sine of 114.4 degrees. So let me do that over here. So the sine of 114.4 degrees. And we already know this would cancel with this. And basically we can just erase this and we'll crank this out in the calculator. And I get about 64.1904. That continues. So I'll round it to the nearest tenth and say it's about 64.2. And this is going to be in terms of inches. So that's where this 64.2 inches comes from. Okay, second triangle. So again, when we think about the measure of angle C, it's 27 degrees. So that didn't change. When we think about our side B, this is 44 inches. That didn't change. When we think about our side C, that's 32 inches. That didn't change. What did change is the measure of angle A is 11.6 degrees here. The measure of angle B is 141.4 degrees here. And then the length of side A, again, opposite of this angle A, now that's going to be 14.2 inches. So again, you could just say you have little a, and let's speed this up. We're going to say this is equal to, the ratio I'm going to use, I'm going to go ahead and take the length of this guy, my little c is going to be 32 inches, over the sine of your angle C, which is 27 degrees. And I'm going to multiply by the sine of my angle A. So the sine of this 11.6 degrees. Again, how did I get this? This would have been little a, or the length of this side right here, divided by the sine of A. And again, A is 11.6 degrees. So you'd multiply both sides by the sine of 11.6 degrees to clear that denominator, and we would have this set up here. So let's just key this into the calculator. And I get about 14 point, let's just say 2 if you round to the nearest tenth. So that's where this 14.2 inches is coming from. So again, this would be our second triangle. We found that this length right here for this side, again, opposite of this angle A, we call this little a, this is 14.2 inches. And then the other two guys that changed, this is 11.6 degrees for my angle A, and this is 141.4 degrees for my angle B. The angle C, again, is the same in each triangle, 27 degrees. My side B is the same in each triangle, it's 44 inches. And my side C is the same in each triangle, it's 32 inches. All right, let's take a look at problem number 9. So here, the measure of angle C is 149 degrees. So again, this is an obtuse angle. So if you're given an obtuse angle, then you're only going to have either one triangle or no triangle. It's not possible to have two triangles. Then we're given the length for side B, that's 40 feet. And then the length for side C, that's 47 feet. The rule for working with an obtuse angle, remember, this is the largest angle in your triangle. So it needs to be opposite of your largest side. So here, this guy is opposite of this side, again, with lowercase c for the name, and the length is 47 feet. That is larger than the length of this side here, B, which is 40 feet, so we're okay. That means we'll have exactly one triangle. So once you figure that out, just go into solving the triangle, and I'll say that the sine of, again, this angle B over the length of the side B, so this is going to be 40 feet, would be equal to the sine of our angle C. So C, the measure is 149 degrees. Then this is over the length for your side C, so that's going to be 47 feet. Okay. At this point, I think we know we're just going to multiply both sides by 40 feet. Let's do that over here as well. And so this is going to cancel with this, and I'll just erase this so it's more clean. And let me cancel the feet with the feet there. So your sine of B is going to be equal to the sine of 149 degrees times 40 over 47. So let's just key that into the calculator, and I get about 0.4383. Let's just cut it off there. So I'll say the sine of B, and again, it's going to be an approximation, but I'm just going to say equals. Let's put 0.43833. Let me get rid of this, and then I'm going to use my inverse sine function. So let's just say that B is equal to the inverse sine of this value right here, so 0.43833. Let me get rid of this, and I'll just say that this guy is going to be equal to, again, key that into the calculator, and I get about 26 degrees if I round to the nearest tenth. So let's just say B is about 26 degrees. Okay, so knowing that there's only one triangle, I can just immediately say that A, the measure of that angle, is going to be 180 degrees minus 149 degrees minus 26 degrees, and that's going to be 5 degrees. So now I have my 3 angles and I have 2 sides. So to get the final side or the missing side, which is going to be your side A, what you could do is, again, just take the information you started with. So this guy and this guy, build a little ratio. So let's say the length of side C is 47 feet over the sine of this angle C. Again, the measure is 149 degrees. Let's say this is going to be equal to, we're trying to get the length for little a. So let's put that there. And this will be over the sine of your angle A, which again is 5 degrees. Now we know at this point we're just going to multiply both sides by the sine of 5 degrees. So let me do that over here. And of course, this will cancel away. And let me just erase it so it's more clean. And we'll say that A is equal to the sine of 5 degrees times 47 feet over the sine of 149 degrees. Okay, if I key that into my calculator, I get about 7.9534. And again, if I want to round to the nearest tenth, let's just go ahead and say this is about 8 feet. So I'll just put that my side A, it's going to have a length of about 8 feet. So if you want to look at the little triangle that's sketched here, our angle C was given. It was 149 degrees. Then we estimated our angle B to be about 26 degrees, and we estimated our angle A to be about 5 degrees. We were given the length of this side C, so this is 47 feet. We were given the length of this side B, this is 40 feet. And then again, we estimated the length of this side A here to be about 8 feet. All right, for problem number 10, here we have the measure of angle B is 121 degrees. We have the length of side A, that's going to be 21 feet. And then the length of side B, that's going to be 34 feet. In this case, we have an obtuse angle. So you either have one triangle or no triangle. So this guy right here is going to be your largest angle. So the side opposite, which is this B guy here, needs to be the longest side. So is this guy right here, this length of 34 feet, greater than this guy right here, this length of 21 feet? Yes, it is. So that means we have one triangle. So I'm going to immediately go in to figuring out, well, what is the measure of angle A? And then I can figure out what is the measure of angle C. And then I can also get the length of that side C that's unknown. So let's go ahead and say that the sine of A over my little a, which again, the length here is 21 feet, would be equal to the sine of my angle B, that's 121 degrees, over the length of my side for B, that's going to be 34 feet. Again, all I need to do here is multiply both sides by 21 feet. So I'm just going to do it on this side, and then I can show it over here, although we know what's going to happen. We're going to end up just canceling this away, and I'll just erase it, okay, just to make it more neat. So let's punch this into the calculator. We know the units here would cancel. So to speed things up, just go ahead and hit sine inverse of this in your calculator, and let's see what that gives me. And I get about 32 degrees if I round to the nearest tenth. So let's just say that A is about 32 degrees. If you're having trouble typing that into your calculator, again, you can just go slower. So the first step, again, is just to calculate the sine of A, and that would have been about 0.52, let's say 94. So let me write this out in case you're lost. So this would be about 0.5294. And then if you go sine inverse of this value, so 0.5294, that's going to give you an approximate measure for your angle A. So let's key this into the calculator. Again, we should get about 32 degrees. And it's not exactly the same, but it's very, very close. So I get 31.9649. It's a little bit different than the other one because with the other guy, you get a more accurate answer because you were typing everything in versus this one where you're cutting a lot of stuff off. But either way, if you're rounding to the nearest tenth, you get about 32 degrees. So let's just keep that answer there. And then for angle C, let's just do 180 degrees minus 121 degrees minus 32 degrees, and then you get about 27 degrees. Okay, so now we need to figure out this missing side, which is C. So again, just use what you were given to make it more accurate. So let's do this little b guy here. So 34 feet, that length, over the sine of your angle B, which is 121 degrees. Again, this would be equal to, you're looking for this little c, and it would be over the sine of C. So the sine of 27 degrees. Again, we know at this point we're going to multiply both sides by the sine of 27 degrees. So let's just speed this up. So this would be equal to little c, or the length of that side C. So let's just punch this into the calculator and see what we get. If I round to the nearest tenth, I get about 18, and this is going to be in terms of feet. So let's just say that C is about 18 feet. Okay, let's look at the sketch. Again, we were given that our angle B was 121 degrees. Then we estimated that our angle A was 32 degrees and our angle C was 27 degrees. We were given the length of this side B was 34 feet and the length of this side A was 21 feet. And then again, we estimated the length of this side C to be about 18 feet. All right, let's take a look at the practice test. For the instructions, we're asked to solve each triangle ABC. We want to round your answers to the nearest tenth. All right, for the first problem, we're given that the length of side A is 17 feet. We're given that the measure of angle B is 112 degrees. And then the length for side C is 26 feet. So once again, if you're trying to solve a triangle, it doesn't matter if it's a right triangle or an oblique triangle, you want to create a little simple sketch and put down the information that you're given just so that you can visually see what's going on. So I have a little sketch here, and you can see immediately that we have side, angle, side. So when you have side, angle, side, you want to use your law of cosines to solve the triangle. And the first thing you would do here is figure out what is the length of this guy right here. Let's just call it side B since it's opposite of this angle B. And so to find the length of side B, we can use our formula from the law of cosines where we say that B squared is equal to A squared and then plus C squared and then minus 2 times A times C times the cosine of that included angle here. So let's just say it's angle B for right now, and we'll plug in the 112 degrees in a moment. So this is your formula. Again, it changes based on what side you're trying to find the length of. So what we're going to do here is just plug in what we know. The length of side A is 17 feet, and for the length of side C, it's 26 feet, and then for my angle B is 112 degrees. Now I'm going to leave the units off because we know at the end of the day this will be in terms of feet, so don't even worry about it. I'll just say that B squared is equal to, again for A it's 17, so 17 squared, plus for C it's 26, so 26 squared, and then minus 2 times A is 17, times C is 26, and then times the cosine of my angle B, the measure there is 112 degrees. So let's take the square root of each side. And on the right side, you only need the principal square root. So I'm just going to say this is B is equal to the principal square root of this stuff right here. So 17 squared plus 26 squared minus 2 times 17 times 26 times the cosine of 112 degrees. So let's just key this into the calculator. And I get about 36 if I round to the nearest tenth. So let me actually erase all of this. And we'll say the length of this side B right here is about 36, and this is feet. So let's say this is about 36 feet. Now the next step is to find the measure of angle A and the measure of angle C. Now typically we'll use the law of sines to do this, but I want you to remember when you end up using the inverse sine function, you cannot get an obtuse angle out of that. So because this guy right here is an obtuse angle, you can actually figure out what is the measure of angle A or what is the measure of angle C using the law of sines. You don't have to really do anything special there. But if this was not an obtuse angle, you would want to solve for the smaller of the two angles so that you don't end up with the wrong angle measure because of the inverse sine function. So I'm just going to stay consistent with that just so we don't make a mistake in the future. So if I look at this side right here, the length is 17 feet. So that's opposite of this angle A. And then the length right here for this side is 26 feet, so that's opposite of this angle C. So what I know is that this angle right here, since it's opposite of the smaller side than this angle right here, which is opposite of this guy, it's going to be the smaller of the two. So I'm just going to say that the sine of this angle A over the side opposite, which is 17 feet, so that length, is equal to the sine of my angle B, in this case it's 112 degrees for the measure, over the side opposite of that, the length is 36 feet. So let's plug that in there. So what I could do here is just multiply both sides by 17 feet. So let's do that over here. And so this is going to cancel with this. And so my units over here are going to cancel away. And we're just going to key this into the calculator and get that the sine of A is equal to the sine of 112 degrees times 17 over 36. Now, you could speed this up and actually get a more accurate answer and just say that A is equal to the inverse sine of this guy right here. So the sine of 112 degrees times 17. and then this will all be over 36. So let's just punch this into the calculator and save a little time. And I get about 26 degrees. Again, if we're rounding to the nearest tenth, and I'll just say that this is about 26 degrees. Now for the measure of angle C, again, you could just do 180 degrees, which is the sum of the measures of all the angles in a triangle, and then minus 112 degrees, and then minus 26 degrees, and that's going to be 42 degrees. So solving this triangle, we found that the measure of angle A is about 26 degrees, the measure of angle C is about 42 degrees, and then the length of side B is about 36 feet. And just for the sake of completeness, we can just write this out. So the measure of angle C is about 42 degrees, the measure of angle A is about 26 degrees, and then the length for side B is about 36 feet. All right, let's take a look at problem number 2. So here we have the length of side B, that's 23 centimeters, and then we have our angle C, the measure is 100 degrees, and then the length of side A, that's 24 centimeters. So again, I recommend making a sketch, and you can see you have side, angle, side. So we're going to use our law of cosines. Now we're going to think about first solving for the length of this side right here. So this side is opposite of our angle C, so let's call it lowercase c. So for the length of this side, again, we can use the formula. We'll say c squared is equal to, you're going to have a squared plus b squared, then minus 2 times a times b, and then times the cosine of, again, this included angle here, which in this case, it's going to be c. So just plug in for the length of side A, in this case, that's going to be 24, forget about the centimeters. The length of side B, in this case, that's going to be 23, again, forget about the centimeters. And then for the angle C, the measure is 100 degrees. So we're just going to plug in. All right, so to speed this up, we know we're going to end up taking the square root of each side. So let's just say that C is equal to the principal square root of, for A, again, I want 24, so this is going to be 24 squared. And then plus for B, I want 23, so this is going to be 23 squared. And then minus 2 times 24 times 23. Let me slide this down a little bit so it fits in here. And then this is going to be times the cosine of, again, the measure of angle C is 100 degrees. So let's just key this into the calculator. And if I round to the nearest tenth, I get about 36. So let's get rid of this and just say that this is going to be about 36 centimeters, again, for the length of side C. So now we have to figure out our 2 missing angle measures. So what is the measure of angle A and what is the measure of angle B? Now again, this is an obtuse angle. So really I could find either one of these guys using the law of sines and I'd be okay. If this is not an obtuse angle, then you need to find the smaller of the two to start. So what I'm going to do is actually just, again, stay consistent. So this side right here is smaller than this side. So that means this angle right here will be smaller than this angle right here. So I'm just going to say that the sine of my angle B over, we're going to say the length for side B, that's going to be 23 centimeters, is equal to the sine of my angle C, which is 100 degrees, over the length of my side C, which is 36 centimeters. What we would do here is multiply both sides by 23 centimeters. So let me show that over here. So 23 centimeters and then times 23 centimeters. And so let's show this as canceling with this. And then I'll cancel these units away. And again, I'm just going to erase this over here, make it a little bit cleaner. And you can just speed this up by doing your inverse sine function. So we'll go inverse sine of this guy right here. So we'll have the sine of 100 degrees, then times 23, and then over 36. So this would give me an approximate measure for my angle B. So let's just say that B is equal to this. And let's just key this into the calculator. And I get about 39 degrees. So let me get rid of this. And we'll just say that this is about 39 degrees. And again, I can just say 180 degrees minus 100 degrees minus 39 degrees would be 41 degrees. So that's my approximate measure for angle A. So let's just write this out and say the measure of angle A is about 41 degrees. The measure of angle B is about 39 degrees. And then the length for side C is about 36 centimeters. All right, let's take a look at problem number 3. So here we have the length of side A, that's 18 miles. The length of side C is 17 miles. And then the length of side B is 30 miles. And again, just make yourself a little sketch. So we have side, side, side. So we're going to use the law of cosines. And what we want to do specifically here is just think about the largest angle that's involved and solve for that guy using the law of cosines. So this angle B here would be the largest angle because it's opposite of the longest side. So let's just go ahead and say that my formula is b squared is equal to a squared plus c squared, then minus 2 times a times c, and then times the cosine of this angle B. What you'd have to do here, since you know the length of side B, the length of side A, and the length of side C, you're going to solve for the cosine of B. Let me actually grab this real quick, and let's paste this in here so we have a little room to work. So what I would do is say that this is B squared. I'm just going to subtract away A squared, subtract away C squared like this, and then I'll say this is equal to the negative of 2 times A times C times the cosine of B. I'll just divide both sides by negative 2AC. Like this. And so this would cancel. And so I'm going to write this as the cosine of B is equal to, I'm going to change this up just a little bit by applying this negative to everything in the numerator. So in other words, I'll say that this is negative B squared, then plus A squared, then plus C squared over, down here, this will just be 2AC, right? So it's just like I said, that I'm multiplying this up here by negative 1. And that's all I did. I just distributed the negative to everything. And now down here, this is positive. Now, you could rearrange this if you wanted to. Typically, the book will write a squared plus c squared minus b squared. So let me actually just slide these down here just to stay consistent with what you're probably going to see. So let me just write minus b squared there. Okay, so let's grab this now. And I'm just going to come back up here and plug in for what we know. So the length for side A is 18 miles. Forget about the units. We're just going to say 18. So I'm just going to plug in an 18 there. And I'm going to plug in an 18 down there. Let me move that over there. And then for the length of side C, that's 17. Again, forget about the miles. So I'm going to plug in a 17 there. And then I'm going to plug in a 17 there. And then for the length of side B, that's 30. Again, forget about the miles. So I'm going to plug that in there. Now you could key this into your calculator as is, but again, now you have to do another step, right? You have to take that value and then plug it into the inverse cosine function. So it's probably easier just to say that B is going to be equal to the inverse cosine of this guy right here. Okay, so let's plug it in like this, and I get about 118 degrees if I round to the nearest tenth. So let's go ahead and say that this is about 118 degrees. All right, so now I have this angle measure, which is the largest angle measure, and I have this side right here. So what I can do is use my law of sines to either find this guy or this guy. It really doesn't matter at this point because I'm not going to run into trouble with the law of sines because I already have the largest angle measure. I don't have to worry about it anymore. So I can say that the sine of this guy B, which is 118 degrees, over the length of side B, which is 30 miles, is equal to, you're going to have, let's just say A, so the sine of this angle A over the length of side A, which is 18 miles. Okay, so let's go ahead and multiply both sides by 18 miles. And I'll cancel this with this, and I'll cancel these units away. So again, you could just punch this in like it is, and that's going to give you the sine of A, but it's a little bit quicker if we just say that A is equal to, let me actually flip this around a little bit. I'll move this over here, get rid of this, get rid of this, and I'll say the measure of angle A is equal to the inverse sine of this guy right here. So let's just key that into the calculator, and that gives me about 32 if I round to the nearest tenth. So let's say the measure of angle A is about 32 degrees. And then for the measure for angle C, let's do 180 degrees minus 118 degrees minus 32 degrees. And that's going to be about 30 degrees. So I'll say that the measure of angle A is about 32 degrees. The measure of angle B is about 118 degrees. And the measure of angle C is about 30 degrees. All right, let's take a look at problem number 4 now. So here we're given a length for side A of 25 feet, a length for side C of 27 feet, and then a length for side B of 28 feet. All right, so going to a little simple sketch, we can clearly see that we have side, side, side. So when this happens, again, you want to solve for the largest angle in that triangle. Okay, and you're going to do that using your law of cosines. So I want to look at this angle B here, because it's opposite of this longest side here, right? The side here has a length that's 28 feet. So what you would do here is go to your B squared is equal to A squared and then plus c squared. And then you'll have minus your 2 times a times c times the cosine of b. So this right here, again, is what you want to solve for. I know what the length of side B is, the length of side A is, and the length of side C is. And again, this is just the length of side A and C. Again, this is the guy that I don't know, okay? So I'm going to solve for this and then use my inverse cosine function, and that's how I'm going to get the measure of angle B. So let's just grab this real quick, and we'll paste this in. And again, real simple, just subtract A squared away from each side and C squared away from each side. So that gives me B squared minus A squared minus C squared. This would be equal to negative 2AC times the cosine of B. I'm going to divide both sides by negative 2AC. Let's do that over here as well. And I'm just going to show that this is going to cancel with this. So now I'm left with just the cosine of B on the right-hand side. On the left-hand side, I'm actually going to move this negative up here. So let's say this is the negative of B squared minus A squared minus C squared like this. And this will be over 2AC. Let me make this a little bit cleaner here so you can see what it is. And all I did was I took that negative from here and I just brought it up here. Okay, so coming down here, I'm just going to finish things up by distributing the negative and rearranging some terms. And actually, let me put the cosine of B over here on the left because that's where I like it. And then I'll say that this is negative B squared and then plus A squared and then plus C squared. And this is over 2AC. Now you can leave it like this if you want, but again, most books will write it as A squared plus C squared minus B squared like this over the 2AC. That's going to be for the cosine of B. So let's grab this real quick, come back up here and paste this in. And all I want to do is plug in for A, B, and C, right? So the length of side A is 25 feet. Forget about the units. I'm just going to plug in a 25 there. And then the length of side C, that's 27 feet. Again, forget about the units. Just going to plug in a 27 there. Let me fix that exponent. And then the length of side B, again, this is the longest side here. That's going to be 28 feet. So let me just plug in a 28 and then square that. And then down here in the denominator, it's 2 times A times C. So again, the length of side A is 25, forget about the feet. And the length of side C is going to be 27, forget about the feet. So I'm just going to put, this is times 25 and then times 27. This would give me the cosine of B. To speed things up, again, if I'm trying to find out the measure of angle B, well, I'm going to say this is equal to the inverse cosine of this guy right here. If you want to do it the other way and find the cosine of B first, well, then you still have to plug that in to the inverse cosine function to get your approximate value for the measure of angle B. Let's just key this into the calculator and be done with it. And I get about 65 degrees, rounding to the nearest tenth. So let's put that in there. And let's get rid of this now. So I have one angle measure here. And again, this is the largest angle. So because I have the largest angle, I know that this is not going to be obtuse and this is not going to be obtuse. So I can use the law of sines to solve for either of these missing angle measures. So I'm just going to pick, let's just say the measure of angle A. I'll just work with that. So I'm going to say that the sine of this angle B, so let's just say this is 65 degrees, over the length of side B, so that's going to be 28 feet. This is equal to the sine of my angle A over the length of side A, so that's 25 feet. So I'm just going to multiply both sides by 25 feet. So let's do that over here. So this would cancel with this, and then feet would cancel. And so I'm just going to write that the sine of A is equal to, you're going to have the sine of 65 degrees times 25 over 28. Now again, you could punch that into your calculator and figure out what is the sine of A, but you've got to take that value and then plug it into the inverse sine function. So we might as well just say that A is equal to the inverse sine of this guy right here. Let me just copy it real quick. And I'll just paste it in so we don't have to write it again. Close that down. We can just get rid of this for now. So let's key this into the calculator and see what we get. And if I round to the nearest tenth, I get about 54 degrees. So let's say that this guy, the measure of angle A, is about 54 degrees. And again, at this point, you could just do 180 degrees minus 65 degrees minus 54 degrees. And that gives me 61 degrees. So the measure of angle A is about 54 degrees. Then the measure of angle B is about 65 degrees. And the measure of angle C is about 61 degrees. All right, let's take a look at problem number 5. So here we're given a length for side A of 19 yards, a measure for angle B of 130 degrees, and then a length for side C of 14 yards. So looking at the little sketch, we can see we have side angle side. And so the first thing I'd want to do is figure out what is the length of this side here. Let's just call it B, right? Since it's opposite of the angle B. And so for this, I would say that B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of B. So what I'll do is just speed this up and say that B is equal to the principal square root of this stuff right here. And I'll just plug in as I go. We know the length of side A is 19 yards, but I'm just going to use 19, forget about the yards. And the length of side C is 14 yards, but again, I'm just going to use 14, forget about the yards. So A squared, so you'd have 19 squared, and then plus for C squared, you'd have 14 squared, and then minus 2 times A is 19, times C is 14, then times the cosine of, again for B, it's going to be 130 degrees. Let's close that down there. Let's just key that into the calculator. And I get about 30 if I round to the nearest tenth. So let's get rid of that and just say this is about 30 yards. Maybe I can make the 3 a little bit better. We need to solve for the measure of angle A and the measure of angle C. Typically, what you'll see in your book, again, they'll tell you to solve for the measure of the angle that's smaller. Okay, and the reason we do that is because the inverse sine function cannot give me an obtuse angle. But in this case, I already have my obtuse angle, so it's not going to matter because A will not be obtuse and C will not be obtuse because you can only have one obtuse angle in a triangle. So you could pick A and you could pick C. Now it is going to matter a little bit here because we're rounding to the nearest tenth, so you'll get a slightly different answer. If you want the answer that's given in the practice test, then what you actually have to do is solve for this guy right here. Okay, and I'm going to show you both just so you can see in case you're a little bit lost in terms of why you got a different answer. So let's start with this one actually, because it's the smaller of the two. This is typically what you would do. So basically I would say that the sine of my angle C over the length of side C, so this is 14 yards, this would be equal to the sine of my angle B, so that's 130 degrees, over the length of side B, so that's going to be 30 yards. Let's multiply both sides by 14 yards. So let's do that over here. And I'm just going to cancel this out and then cancel this with this. And let me erase this completely so it's more clean. You can actually erase those units. You don't need them. And what I'm going to do is actually say that C, the measure of that angle, is equal to the inverse sine of this guy right here. So I'm just going to punch this into the calculator and I get about 20.945969, and I'll just stop there. The problem is if you round this to the nearest tenth, you're really going to get about 20.9 degrees. So I could say that C is about 20.9 degrees. And the answer given in the practice test is 21 degrees. So if you went with this, it's fine. We're just doing an approximate answer. So we would go through and say 180 degrees minus 130 degrees minus 20.9 degrees would give me a measure for angle A of 29.1 degrees. Again, on the practice test, it's going to be off by 0.1 degrees because this would be 29 degrees. So the other way you could have done this will actually give you 29 degrees here, and it will give you 21 degrees here. Okay, so this will match the practice test. And what you would do is you would actually solve for angle A. Now remember, this is okay because we already have our obtuse angle here, so this isn't going to affect anything. So you could just change this to A, and then instead of 14, you would use 19. So let's put this in here. And I'm just going to key this into the calculator with you. And you're going to see when you round to the nearest tenth, you're going to get about 29 degrees here. So I get about 29.023052, and I'll just stop there. You round that to the nearest tenth, you're going to get about 29. So if I did it that way, I would get 29 degrees here. And then again, 180 degrees minus 29 degrees minus 130 degrees. Now I would have 21 degrees here. So if you got a different answer, it's okay. Remember, we're approximating these things. It's just the general idea that we're looking for. Okay, so your answer can be slightly off. It's not that big of a deal. Let's just say that the measure of angle A is about 29 degrees, or again, about 29.1 degrees if you did it the other way. Then the measure of angle C is about 21 degrees, or it could have been about 20.9 degrees if you did it the other way. And then the length of side B is about 30 yards. All right, let's take a look at problem number 6. So here we have the length of side A is 11 centimeters, the length of side C is 17 centimeters, and the length of side B is 10 centimeters. So this is a situation with side, side, side. So what you want to do is use the law of cosines to solve for the largest angle in that triangle. So in this case, the longest side is 17 centimeters. So that's going to be my side C, and it's opposite of my angle C. So I'm going to solve for this guy because this is going to be the largest angle. It's opposite of the longest side. So we'll say that C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of C. So what you want to do is solve for the cosine of C. So again, I think we can fit this in here. I'll just say this is C squared minus A squared minus B squared. And this would be equal to the negative of 2AB times the cosine of C. Let me actually get rid of this and let me slide this up here. What I'm going to do is divide both sides of the equation by negative 2AB. So do that over here as well. So this is going to cancel away. And you'll say that you have the cosine of C is equal to. So again, I'm going to bring this negative up here. So I'm going to erase it from here and put a negative 1 up here like this. So this would be negative C squared and then plus A squared and then plus B squared. And this is over 2AB. And all I'm going to do now is say that the cosine of C is equal to, I'm going to write this like your book does. So A squared and then plus B squared and then minus C squared. And this will be over the 2AB. Okay, let's get rid of this. Now, what I would do is actually say that C is going to be equal to the inverse cosine of this guy right here. So we would just plug that into the calculator and we'd be good to go. So for the length of side A, that's 11 centimeters. Forget about the units. I'm just going to plug in 11. For the length of side B, it's 10 centimeters. So I'm just going to plug in a 10. And then for the length of side C, it's 17 centimeters. So I'm just going to plug in a 17. And then down here, again, for A, you want 11. And then for B, you want 10. Okay, let's key this into the calculator. And I get about 108 degrees. So let's put that in here. So this is about 108 degrees. So again, I've found my largest angle. So I can use the law of sines to find either angle now. So I'm just going to work with, let's say this one. So I'll say that the sine of B over my length for side B, that's going to be 10 centimeters, is equal to the sine of my angle C, which is 108 degrees, over the length of side C, which is 17 centimeters. So I'll just multiply both sides by 10 centimeters and see what that gets me. So we can see that this is going to cancel. Centimeters would cancel. You can actually just erase this from over here. And what I'll do is I'll just say that B is equal to the inverse sine of this whole thing here. And maybe I'll just erase these units here to make it a little bit cleaner and collapse this down a little bit. And we'll just key this into the calculator. And I get about 34 degrees. So I'll say this is about 34 degrees. And so for the measure of angle A, again, 180 degrees minus 108 degrees minus 34 degrees, that's going to give me about 38 degrees. So let's say the measure of angle A is about 38 degrees. The measure of angle B is about 34 degrees. And the measure of angle C is about 108 degrees. All right, let's take a look at the next section where the instructions tell us to find the area of each triangle ABC. Round your answers to the nearest tenth. So for problem 7, we're given the length of the side A is 9 meters, the length of the side C is 15 meters, and the length of the side B is 16 meters. If you have side, 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 and you're trying to find the area, again, you're going to use that Heron's formula. So first you need to figure out what is S, right? So S is the semi-perimeter. So 1/2 times A plus B plus C. So in this case, the S is going to be 1/2 times A is going to be 9 meters. Let's just leave the units off. So let's just say this is 9 plus B is going to be 16, and then plus C is going to be 15. So this is going to be 9 plus 16, which is 25. And then 25 plus 15 would be 40. So 40 divided by 2, or 40 times 1/2, would be 20. So let's say that this S, or again, that's the semi-perimeter, this is going to be 20. So what you want to do is plug into this formula now. So the area is equal to the square root of S times, you're going to have S minus A, and then times S minus B, and then times S minus C. So just plug into this guy. So again, this is a 20. Everywhere you see an S. So this is a 20 here, and here, and here, and also here. And then for A, we know that that's 9, so let's plug that in there. And then for B, that's going to be 16, so let's plug that in there. And then for C, that's going to be 15, so let's plug that in there. So you could simplify this if you want. I'm just going to key it into the calculator and be done with it. And I'm going to get about 66.3. So this is about 66.3. And remember, when you're working with area, it's going to be units squared. So here it's meters. So you could say square meters or meters squared. So this would be about 66.3. Let me make that 3 a little bit better. I'm just going to say meters squared for the area. All right, let's take a look at problem number 8. So here we have the length of side A is 14 centimeters. The length of side C is 13 centimeters. And the length of side B is 16 centimeters. So again, we have side, side, side. So we can use Heron's formula. So first you need the semi-perimeter. So S is equal to 1/2 times A plus B plus C. So S is equal to 1/2 times, for A, forget about the units, it's just going to be 14. Then plus, for B, it's going to be 16. And then for C, it's going to be 13. So 14 plus 16 is going to be 30. And then 30 plus 13 is 43. So you have 43 times 1/2, which I'm just going to write that as a decimal and say it's 21.5. So this is going to be 21.5. And I think it's just a little bit easier to type it into your calculator as a decimal. And so for the formula for area, we'll say this is equal to the square root of, you take the S and you multiply it by S minus A, and then times S minus B, and then times S minus C. Okay, so it's that simple. So everywhere there's an S, you're going to plug in a 21.5. Let me actually get rid of this from here, and I'll just plug it in there. So this is 21, and let me erase this, and I'll just kind of write this back in. So 21.5, and then times, so we're going to go S, which is 21.5, minus A, which is going to be 14, and then times your S, which is 21.5, and then minus your B, which is going to be 16, and then times, let me slide this down here a little bit. You're going to have your S, which is 21.5, and then minus your C, which is 13. Okay, so let's just key this into the calculator. No need to go through and simplify. And I get about 86.8 if I round to the nearest tenth. So let's say that the area here is about, let's make that E a little bit better, 86.8. And again, this is going to be units squared. So it's going to be centimeters squared. Okay, let's take a look at problem number 9. So here we have the length of side B is 6.8 inches. We have the measure of our angle C is 120 degrees. We have the length of side A is 5 inches. Now, coming down here, we see we have side angle side. So we talked about in the lesson for the law of sines, the first one, how you could get a little formula to find the area if you had side angle side. So basically, the area here can be found really quickly as 1/2 times this side times this side. So let's just go ahead and say 6.8. Forget about the units. We know it would be inches squared in the end, so let's just forget about the units. And then times 5, and then times the sine of the included angle. So the included angle here is 120 degrees. So let's just key this into the calculator real quick. And I get about 14.7. And again, this is going to be in terms of square inches or inches squared. So 14.7 inches squared. Now, what I want to do is actually find the area using Heron's formula with side angle side. Now, this is not something you want to do. It's just to get extra practice. Some teachers will make you do this in this section just so you get a lot of practice using all of the formulas together. Okay, so I'm actually going to get rid of this, and I'm just going to start by figuring out the length of this side right here because you would need it for Heron's formula. So let's just go ahead and say that C squared is equal to A squared plus B squared minus 2AB times the cosine of your angle C. So what I'm going to do is say that C is equal to the square root of this stuff right here. So I'm just going to go ahead and plug in for A. That's going to be 5. Forget about the units, so 5 squared. And then plus for B, I'm going to plug in 6.8. And that's going to be squared. Let me wrap that so that's clear. And then minus 2 times, you're going to have 5 times 6.8 times the cosine of 120 degrees. Let's punch that into the calculator, and I get about 10.3. So let's say that this right here is about 10.3 inches. So now that you have that, again, you can use Heron's formula and say that S, the semiperimeter, is 1/2 times A plus B plus C. So 5 plus 6.8 plus 10.3, that's going to be 22.1. So let's do the multiplication, and I get 11.05. So let's put that in there. So again, your area would be equal to the square root of, you're going to take this S, so 11.05, and it's multiplied by, you go S minus A times S minus B times S minus C. So you're going to go 11.05 minus, for A you have 5, then times 11.05, then minus, for B you have 6.8, and then times, this is probably going to run off, so let me slide this down a little bit. We'll say that we have 11.05 minus, for C, you have 10.3. Okay, let's close that down. Let me get rid of this. Let's just key this into the calculator. So I get about 14.6 if I round to the nearest tenth. And again, it's just a difference in rounding. So I'm just going to say that my area is about, let's just go back to the 14.7 inches squared. Again, if you use the other method, you're going to get about 14.6 inches squared, but the difference is just because of rounding. All right, let's take a look at problem number 10. So here we have the length of side A is 15 miles. The measure of angle B is 78 degrees, and the length of side C is 12 miles. So again, we want to find the area, and I'm going to do it both ways. Again, if you're given side angle side, it's quicker and better to just use that formula we learned about with the law of sines. So you could say that the area here is equal to 1/2 times this side times this side. Just leave the units off. We know it's going to be miles squared or square miles. So we'll say 15 times 12, and then times the sine of the included angle, which is 78 degrees. Let's just punch this into the calculator, and I get about 88. So the area would be about 88 square miles. Okay, so I'm not even going to write that because I'm going to do it the other way as well. So let's get the length of this side right here, which we would say, this is side B, it's opposite of angle B. So we're going to say that B squared is equal to, you have A squared plus C squared minus 2AC times the cosine of B. So let's say that B is equal to the square root of all of this. And I'm just going to plug in as I go. So for A, it's going to be 15. Forget about the units, squared. And then plus for C, it's going to be 12. And that's going to be squared. And then minus 2 times 15 times 12. And then times the cosine of, for B, it's 78 degrees. Let me slide this down so it fits. So this is 78 degrees. Let's key this into the calculator. And I get about 17.2. So this would be about 17.2 miles. So now we need to get our semi-perimeter. So this guy plus this guy plus this guy times 1/2. So 17.2 plus 15 plus 12, that's going to be 44.2. Then if I divide by 2 or multiply by 1/2, I get 22.1. So we'll say that S, the semi-perimeter, is going to be 22.1. So then for the area, this is going to be equal to, again, the square root of, you're going to take this guy, so 22.1, and then times, you're going to go 22.1 minus your A, so that's 15, forget about the units, and then times 22.1 minus your B, that's going to be 17.2, and then times your 22.1 minus your C, which is going to be 12. Let's key this into the calculator, and again, I get about 88, rounding to the nearest tenth. So let me get rid of this, and either way, it's going to be about 88 if I round to the nearest tenth. So let me just put that the area is about 88. And again, this is going to be square units. So in this case, it's miles. So we'll say miles squared, or you could say square miles. All right, let's take a look at problem number 11. So here we are asked to derive Heron's formula. So this is not something that I expect you to be able to do on your own. Some people would be able to get this on their own, but for most people, including myself, it's something where you need to see it either from a teacher or from a book, and then you can go through the steps and you can see where this is coming from. So the first thing is I'm just going to start out with the area, and I'm going to write out the word area. If you're using a book, they probably have a fancy A to denote area. I can't draw that, so I'm just going to write the word area. And we're going to say this is equal to, now we saw this formula earlier in the practice test, and also, again, for the first part when we're talking about the law of sines. Let's say you had the length of side A and the length of side B, and then also you had the measure of the included angle there, which would be C. So you could say that the area is 1/2 times the length of side A times the length of side B, and then times the sine of the included angle. Again, this is going to be C, right? But specifically, this is the measure of angle C. I think we know that. And then what we would do here is start out by squaring both sides, okay? So let me actually show this. So I'm going to write area, and then I'm going to square that. And then I'm just going to wrap this here. So 1/2 times A times B times the sine of C. And then I'm going to square that. So we know how this works with multiplication. This exponent of 2 needs to be applied to each factor inside the parentheses. Let me slide down here a little bit. And I'm just going to put equals over here. We know that this is area squared. I'm just getting a little room. So this would be 1/2 being squared. So basically that is 1/4. And then times A that's squared. And then times B that's squared. And then times, you could write the sine of C being squared as sine squared C. Okay, so at this point, what you're going to do is make a little substitution. We know that sine squared theta, forget about the fact that it's C for right now, sine squared theta is equal to 1 minus cosine squared theta. That comes from the sine squared theta plus cosine squared theta equals 1. So it's just a different form. So I can replace this right here with 1 minus cosine squared C. So let's say that this is going to be equal to 1/4 times A squared times B squared, and then times, I'm going to put this in parentheses, so 1 minus cosine squared C. Now, what we're going to do from here is use our difference of squares formula to factor this. Remember, if you have A squared minus B squared, this is A plus B, this quantity, times the quantity A minus B like this. Okay, so this is going to factor because you can think about this as 1 squared, right? 1 squared is just 1. So let's go ahead and say that this is going to be 1/4 times A squared times B squared, and then times the quantity 1 minus the cosine of C, and then times the quantity 1 plus the cosine of C. So hopefully you're with me. All I did was factor this into this. Okay, so at this point, we need to go to another page because we need to figure out what is the cosine of C. Okay, so what I'm going to do is solve for the cosine of C. I'm going to use that law of cosines formula that involved the cosine of my angle C. So I'm going to say that this is C squared is equal to A squared plus B squared, then minus 2 times A times B times the cosine of that angle C. So this right here is what I want to solve for. And again, we did this multiple times in the practice test. So I'm just going to subtract A squared away from each side and B squared away from each side. So that would give me C squared minus A squared minus B squared. And this would be equal to negative 2AB, and then times the cosine of C. Now what I'm going to do is divide both sides by negative 2AB. So let's do that over here as well. And what that is going to do for me, this is going to cancel with this. And so I have the cosine of C isolated on one side. Now I like what I'm solving for to be on the left. You could leave it on the right if you wanted to, but I'm just going to flip the sides here. Remember, that's completely legal. So I'm going to say this is the cosine of C is equal to, I'll take this guy right here, and I'm actually going to move this negative up here. So let's say this is the negative of, I'll put C squared minus A squared minus B squared like this. Close that down. I'll say this is over 2AB. So in case you're lost here, remember, if you have a fraction like A over negative B, you could write this as the negative of A over B. So I just took this negative from the denominator, just like I did here, and moved it to the numerator. But remember, you have to distribute that negative to each term, okay? So you can't just move it up in front of the C squared. It can't just be negative C squared minus A squared minus B squared. It has to be the negative of this whole thing, okay? So let's get rid of this, and let's distribute the negative, and I'm going to rearrange things just a little bit. So I'll say that the cosine of C is equal to, this is going to be negative C squared, then plus A squared, and then plus B squared. Okay, so typically your book is going to write this as A squared plus B squared, and then minus C squared like this. So just staying consistent. And then this would be over your 2AB. So we're going to need this. Let me get rid of this real quick. And let me drag this up here. So what we're going to do now is go back up. And you see that we want 1 minus the cosine of C, and then 1 plus the cosine of C. So we're going to come back down, and we are going to figure out, let me put this as a little border here. We need 1 plus the cosine of C, and then we need 1 minus the cosine of C. All right, let's start by finding 1 plus the cosine of C, and then we'll move on to 1 minus the cosine of C. Let me actually just grab this and copy this. Let me erase this and slide this down just a little bit. And all I'm going to do is just add 1 to each side of this equation. And I'm just going to manipulate the right side here. So let's say that this is equal to, for 1, I'm going to write that as 2ab over 2ab, just so that we have a common denominator. And let's say this is plus this guy over here, so a squared plus b squared, and then minus your c squared over 2ab. Now, we have a common denominator, so I can add the two numerators together. And I'm going to put this in a specific order, and that's just so I can factor. So what's going to happen is I'm going to take the a squared first, and then plus, now I'm going to put the 2ab, and then plus the b squared, and then minus c squared. And this is all over 2ab. So hopefully you recognize this pattern right here. So we've seen this a million times in algebra. Let me come down here, and I'll just write it out. If you have x plus y, quantity squared, this is x squared, so the first guy squared, plus 2 times x times y. So you could say 2 times the first guy times the second guy, and then plus the last guy, which is y, that guy being squared. Okay, so that's the exact pattern you have here. You just have different letters involved. So I'm going to say that this is the quantity a plus b being squared. So let's replace this with the quantity a plus b being squared, and then minus c squared, and this is over 2ab. This step right here is going to lose a lot of people. So I'm going to do this in a different way to make it easy for everyone to understand. I'm going to make a substitution here. So we are going to say that we're going to let u be equal to a plus b. Okay, so this right here, I'm going to plug in a u. Okay, and you can drop the parentheses, you don't need them. So I'm going to say that this is u squared minus c squared, and this is over 2ab. Okay, so I think we can see that this is the difference of squares here. It's pretty easy. Let me actually keep dragging this down here. Okay, so we can remember that u is a plus b. Let's come down here, and then I'm going to say that this is equal to, I'm going to factor this. Again, this would be u plus c, and then times u minus c, and this is over 2ab. So again, u is equal to a plus b, so just plug that in there and plug that in there, and you'll be done. So let's come down here, and I'll say that this is going to be a plus b, and then plus c, and then times, you're going to have this quantity a plus b, and then minus c. This is all over 2ab. Okay, so this is going to be for 1 plus the cosine of c. So let me actually grab this result here. I'm just going to come to a fresh sheet here and put that this is 1 plus the cosine of c. So let's actually go back. So let's grab this again, and I'll come to another fresh sheet. So now I'm going to go 1 minus over here, and let me slide this down like this. And I'll put 1 minus over here. And then again, I'm just going to manipulate the right-hand side here. So we're going to say that this is equal to, again, get a common denominator. So 2ab over 2ab, and then minus this guy right here. So a squared plus b squared minus c squared over 2ab. So this part is actually a lot more tricky just because of sign mistakes. So I'm just going to go through each sign mistake that you might make. The first one is this one. Remember, you're subtracting this whole thing away. So if you take this guy right here, this numerator, this 2ab, and you subtract away this guy right here, again, you want to wrap this in parentheses so you don't make a sign mistake, right? So each term has to be subtracted away. So in other words, this would be minus a squared, and then minus b squared, and then plus c squared. So make sure you change the sign of each term. Then this is over your common denominator of 2ab. Okay, so that's the first part. Again, make sure you wrap this in parentheses, otherwise you're going to make a sign mistake, and you're going to keep carrying that mistake throughout the rest of the problem. Let's come down here. And now, this is the part where a lot of people struggle. You have to do something very similar to what you did in the last problem, but it's a little bit more challenging because it's harder to see what you're going to do right away. So the first thing is you have this c squared. You're going to want to write that out in front. So let me just put equals, and I'm just going to put c squared here. And then the next thing is, let me reorder this and say this is minus a squared. And then I'm going to put plus 2ab. And then I'm going to put minus b squared. And this will all be over 2ab. When you look at this as it is, you don't see something that's a pattern that you're used to for factoring, right? So if you think about something like, let's say, a squared minus 2ab and then plus b squared, well, we know if we had that, this would factor into a minus b quantity squared. Now, can I get to this here? Yes. And the way you know that is this sign is opposite of this one, this sign is opposite of this one, and this sign is opposite of this one. If all the signs are opposite of what you need, then you could just factor out a -1 and get there, okay? So let me go really slow here because this is where a lot of people get lost. So let me go c squared. I'm just going to go plus, and I'm going to put a -1 like this so it's crystal clear. Maybe I'll use brackets here. Now, if I'm pulling out a -1 from here, that just means all the signs are going to change. So instead of a -a squared, it's a squared. Instead of a plus 2ab, it's minus 2ab. And then instead of a minus b squared, it's plus b squared. Again, if you go through and distribute the -1 to each, I'm going to get right back to where I was. So this is completely legal. Now, let me change this up just a little bit for formatting. Instead of plus this -1, let's just make this into a minus. Instead of brackets, let's just use parentheses like this. And now this is over 2ab. We know that this factors. So let's say this is c squared minus the quantity a minus b being squared over 2ab. Okay, so now again, we have the difference of squares. Let me come to a fresh sheet here. So we have a lot of room. Again, my recommendation is if you're struggling with this, just use something like a substitution technique. So you can let u or z or w or whatever you want to use. Let's just use u be equal to a minus b. So in this place right here, you're going to plug in a u, okay? And you can just drop the parentheses. So we'll say that this is c squared minus u squared over 2ab. So now let me put equals over here. Let me come down, and I'm actually going to drag this with me so we remember. So let's put equals. We know this would factor into c plus u, and then times c minus u. And this is over 2ab. Now you have to be very careful here as to not make a sign mistake. What's going to happen is this right here is going to get plugged in here and then also here, okay? So let's come down here real quick, and we're going to say that this equals, you can have in parentheses c plus. Now you have a minus b. You could wrap this if you wanted to, like this, and close this down. But we know a plus sign in front of parentheses, you could just drop the parentheses. So this becomes c plus a minus b. That's very straightforward. So for this one, you have c minus. Now here's where it gets tricky. You want to subtract away the whole thing because u is a minus b. So I need to subtract away both of those guys. So you can wrap this in parentheses to make this clear. So minus the quantity a minus b, like this, close that down. So this becomes a -a and a plus b. So this becomes minus a and then plus b. Okay, so this right here is the factored form. This would be over 2ab. So let's grab this real quick and let's paste this in here. So I'm going to put 1 minus the cosine of c is equal to this. All right, so at this point, we need to go back to the original stuff we were working on. So we're going to return here. Remember, the left side is the area squared. So you can write that again if you need to, but I think you remember that. So basically, you're going to plug in for 1 minus the cosine of c, and you're going to plug in for 1 plus the cosine of c. I've got to write this as small as I can, and I'm not really good at that. So let me come all the way over here and say this is 1/4 times a squared times b squared, then times for 1 minus the cosine of c. Again, that's going to be this guy right here. So let me grab that and let me paste this in here, and I'll just copy it so it's smaller. So I'll put times the quantity c plus a minus b times the quantity c minus a and then plus b like this. And this is over 2ab. Okay, let me get rid of this. The other one we have to grab is 1 plus the cosine of c. So that's going to be this one. So let's go times, and I'm going to say this is the quantity a plus b plus c, then times the quantity a plus b minus c. And this is all over 2ab. I'm actually going to grab this and just go to a fresh sheet, just so we have a lot of room. So let's paste this in right here. Remember, the left side here is the area squared. I don't have room to write that, but hopefully you have that in your notes. Now, the first thing you're going to do here is realize that this is all multiplication, right? So this is multiplied by this, multiplied by this, multiplied by this, multiplied by this. So basically, a would be multiplied by a down here, right, in your denominators, and you would have a squared. Now, you could cancel that with this a squared here, So this would cancel with this and this. And then the b squared similarly would cancel with this and this, right? B times b is b squared. All right, now the next part might be a little bit confusing, but I want you to remember that this is just straight multiplication, okay? So in other words, in the numerator, you have 1 times this quantity times this quantity times this quantity times this quantity. In the denominator, you have 4 times 2 times 2. So I know the denominator is 16, but they're going to break that up into 4 factors of 2. So in other words, you're going to take each one of these guys and write it over 2. So let me show you. We're going to start with this a plus b plus c. So that one's going to go first. Let me put equals over here. So a plus b plus c, and I'm going to put this over 2. And then times. The next one I'm going to do to stay consistent with the book, I'm going to use this one here. Remember, you can multiply in any order, so this doesn't matter. I'm going to go c minus a plus b like this, and this will be over 2. And then times, and I think I'm writing this too big, so let me actually slide this down a little bit here. So c minus a plus b over 2. And then times the next guy, I'm going to use this one. So this would be c plus a minus b over 2. And then the last guy, it's going to be this one. So it's going to be a plus b minus c over 2. Again, I haven't done anything illegal. You can pause and think about it. The denominator is going to be 2 times 2 times 2 times 2, which is going to be 16. Down here, if you look at it, it's 4 times 2 times 2, which is 16. And the numerator, again, it's just the product of these quantities. Up here, it's the exact same thing. So we haven't done anything illegal. We've just broken it up in such a way that we're going to be able to get to our formula. Okay, now we know that from Heron's formula, the semiperimeter S is equal to this a plus b plus c divided by 2, okay? So here I can just replace that with S. So let me get rid of this and come down here a little bit, and I'll say this is equal to S. Now, we have this times this guy right here. What you're going to want to do is write that as the quantity S minus A, right? So you're going to want to put this as S minus A, and you're going to want to put this as S minus B, and you're going to want to put this as the quantity S minus C. Now, where does that come from? Let me show you on one of them, and then you can get the other ones on your own if you want. I'm just going to take this one, and it's just a very simple trick. Let's say you had C minus A plus B, and this is over 2. Well, the first thing is I need to get S. So in other words, let me come down here. I'll come back up in a moment. I need to get to the point where I have A plus B plus C. So what could I do legally? Well, I could add 2a up here, but the problem is that's illegal, right? I can't just add 2a to something. So to fix that, I'm just going to subtract 2a away. So what would happen? Negative a plus 2a would be a. So what I could do is say that this is a plus b plus c. And then again, this negative a plus 2a, that's how I got the a over there. So now I'm just left with, let me write this in a different color, minus 2a. Now, this is all over the common denominator of 2. So what you can do here is split this up and say that this is a plus b plus c over the common denominator of 2. So a plus b plus c over 2. And then minus 2a over 2. Remember, if you combine these guys, you have a common denominator, you would go right back to this form right here. So this is legal. So this would cancel with this. And so what I have is this a plus b plus c over 2, which is S, and then minus a. Okay, so that's where that's coming from. So let me get rid of this, and we'll come back down here. So you see where the S minus a came from, and you can use a similar strategy to get this as S minus b, and this as S minus c. Okay, so that's all it's going to be. So S times your quantity S minus A times your quantity S minus B times your quantity S minus C. Now, if you remember from a long time ago, way up there, we said that area squared was equal to, and we've gotten this to this. So this is area squared is equal to this guy. And let me just paste that in there. So how do we get the area? We just take the square root. So the area would be equal to, again, we don't need the negative square root. We just want the principal. So the principal square root of this guy, let me paste this back in. So this is our Heron's formula, and that's where it comes from. It's quite long, and there's a lot of different ways that you can derive it, but I think this is the easiest one to follow. As long as you're really careful and you pay attention to these signs, I think that you're pretty much good to go with this guy. So the area is equal to the square root of S, which again is that semi-perimeter, that a plus b plus c divided by 2, times the quantity S minus A times the quantity S minus B times the quantity S minus C.